I will go. Should we go?
Hi everyone, welcome back. Last day of DevConf. Hope you enjoyed the party last night. And I would like to remind you that there is a special session at the end. Don't forget to attend. And we will always prepare some prizes, as always. And now we have the first session here. We have Andrew and Guido here, and we're talking about middleware automation from the edge to the cloud.
Thank you.
Thanks.
What an introduction for 9:30 in the morning on a Sunday. Thank you. Good morning, everyone. Props to you for getting up early and actually getting here on time. The session today is middleware automation from the edge to the cloud. Next slide. My name is Andrew Block. I'm a distinguished architect here at Red Hat. I am in the Global Services Office of Technology. What we do is we work with customers around the globe to develop common patterns and implement them at scale. I am one of the founders, of the Ansible middleware project that we'll talk about today. I am a big open source advocate. I have mainly these days in the cloud native space. I'm a maintainer on the Helm and Auras project and contribute to a security project called SigStore, which attempts to provide tooling for securing your software supply chain. And I'm an author on a couple different books. Here, Guido.
I'm a long-time mercenary in banks, insurance, breaking monoliths, and working in automation. And then I became a redactor to make it freely available and to give back to the community. Thanks.
Yep. Okay. So, as some of us have already discussed this morning, we're starting to see applications run in many, many different places. We've been running in the public cloud for a number of years, but another trend that was starting to come more recently is running applications at the edge. And that is really because we're starting to see more demand at processing and managing assets closer to where they're being sourced. So look at when we got on the bus today, or the tram. You went ahead and you scanned your phone maybe, you paid. That is another edge device that is currently running out in the field. There may be some processing on there might be some other capabilities. That's just one example. Checkouts at a store, you name it. We're seeing more and more demand where it's needed. So that's incredibly important because you need to manage it somehow. So one of the key tenets of applications running anywhere is a type of application called middleware. So middleware really is the connective tissue between many of your applications. Dang. That's okay. We'll just go ahead. So middleware really is the connective tissue between many different components of an enterprise architecture. It's going to be the plumbing. Our team loves to use the term plumbing because that's what we really see it as being. Without it, you're just going to have nothing because it provides so many different capabilities out there, and it really does power organizations throughout the world. So, question for you. Not you, for them. Who here, show of hands, a little bit of survey time, who here has built and deployed an application to a middleware server? Okay. Who here has managed a middleware server? Okay. Have you used any automation tools to do so? Or has it been manual when you've been managing the middleware server or the applications? And the question is, who here has never heard of middleware before walking in this door today? Okay, we got some new ones. Awesome. All right. I love seeing some new faces for that. Okay, great. Okay, next slide. So one thing that we've seen is that even though there's a lot of popularity in middleware, there's still most of it not being managed in an automated fashion. And that's a huge opportunity that our team sees as providing tooling to close that gap. Next slide. So what are some different ways to manage your middleware portfolio? Well, number one, it's got to run on a server usually. You could obviously manage the underlying libraries, dependencies that your middleware needs. You then have the lifecycle of the middleware server, everything from the installation, the upgrades, downgrading, you name it. The configuration of that server, so that's going to be all the different unique properties for that specific environment, maybe some database URLs, credentials, messaging queues, names, you name it. And finally, the application deployment and management layer on top of that. All the different ways that you can go ahead and automate your middleware portfolio. So the question is, what are different ways to automate it? Well, we can start with scripts, Bash, PowerShell, you name it. There are some underlying specific operating system tools. SysPrep, no, we're looking at the more unique ones. For Windows there's SysPrep. Linux has, what's the one for Rail? I'm blanking on it right now that helps stand it up. Or am I blanking on it? Oh, whatever. I know. The automation tool for, the underlying for standing up a, never mind, I'm going to forget it. Not Tower now. I'll remember, I promise. And then finally, an automation tool.
IBM Urban Code.
Ooh, that's a good one. No, not that one, I promise. And then finally, a specific tool designed for automation. That's going to be something like a Chef, a Puppet, an Ansible. So, how many here has heard of Ansible? Please say yes. How many here has never heard of Ansible? Okay, good. You haven't? Good. Okay, so we can go ahead and we can talk about what Ansible is. Ansible is a simple, powerful, and agentless automation tool for managing automation at scale. It's simple because it doesn't require a lot of special syntax that you need to know under the covers. The tasks themselves, as you define in a declarative fashion, are executed in order, and it can be used by every team. Anyone from your developers or your operations team can use Ansible. It's powerful because it can do everything and make your breakfast too. It could have made breakfast this morning. I don't know. Who knows what those machines are using. It can manage everything from application deployment, configuration management. It has a workflow engine as part of it. It can do network automation. And then finally, one of the most important parts of Ansible is it is agentless. We're looking at automation tools like Puppet and Chef. They are traditionally an agent-based solution. So this is agentless. All it needs to do is connect to an end system via a number of different connection plugins, and you can manage it as you see fit. And it uses, out of the box, OpenSSH and WinRM, depending on what OS you're playing with. So why don't we go ahead and think about combining the power of the benefits that middleware can provide plus the power of Ansible. It's that combination that amazing stuff starts to happen. And that's what our team has gone and designed, is tooling around the ability to manage your middleware portfolio with Ansible. And that's what Ansible middleware is. It really is that set of tools that were specifically designed to manage Red Hat middleware and its underlying runtimes. It has support for multiple middleware products. It is configurable. This is one of the best parts about it, is that every organization and every use case is different. There are quite a number of different ways that you can configure it, would you say?
Oh, well, that's going to be a big number because it's the factorial of that declarative list of tasks.
That's true.
So,
quite a large number.
Well, it's still smaller in the outcome of expected bugs if you compare it to code.
That is true.
Which would be in a bash script.
Yeah. And then finally, this framework, Ansible middleware, is built and run by a team that has not only engineered Red Hat runtimes in the past and current, but also those who have delivered it at customers globally. So you basically have a combination of the two of us. He builds it. I work with customers to roll it out at scale. So this is how easy it is. Simple, easy as pie. This is how easy and all it takes, really, to deploy a JBoss Enterprise Application Platform server. It's simple. Was it 14 lines, Guido? Then we count on 14 lines of configuration. It's a little more you have to configure in the back end, but still a lot easier than the thousands and thousands of lines of bash scripting you may have done in the past or currently are doing today.
It is because we don't follow the practice of pushing out products with basic defaults. We use opinionated defaults, which provide a production-ready, enterprise-grade deployment, even if you do not override configuration. Of course, it is opinionated, so it doesn't work 100% of the times, and that's why you can override with your environment configuration.
Yep. As easy as that. So what are some of the benefits? Oh, Ansible middleware. You have that consistent deployment to be able to manage and scale your applications as you see fit. Write once, deploy anywhere without manual intervention. We talked about being able to manage different systems at the cloud or the edge. You can go ahead and use the same baseline configuration and then have specific environment overrides that can make it so it's speed defined and used in these different environments. Maybe you want to specify your JVM with a smaller heap size in certain environments, or you have a different profile you want to go ahead and run out. Those can be overridden per environment. You can use the power of Ansible Automation Platform to then be able to then orchestrate at scale. We'll talk a little bit more about how you can integrate Ansible Automation Platform into this entire ecosystem. It has seamless integration for upgrades, downgrades, install, uninstall, configuration management, scaling, and more. And then obviously you can save time by reducing the manual errors that you would have by using other more traditional based approaches. So what kind of different technologies do we support? Well, think about all the different types of middleware that's out there. We have everything from managing a web server, an enterprise, to then manage systems that manage enterprise applications, to messaging, caching, identity. All these different capabilities and technologies are available to be managed via Ansible middleware. So what does that translate to into projects in the upstream community? So for web, we have Tomcat. For more of enterprise application, you have Wildfly as your application server. If you want to go more towards the caching set of things, you go ahead and use Infinispan. Identity with Keycloak, one of the newest CNCF sandbox projects. And then finally, if you're looking on the messaging side, there are two flavors of messaging that we support. Traditional JMS brokers with ActiveMQ and Apache Kafka for the streaming Kafka-based approach. But Guido and I are both working for Red Hat. We also support the enterprise version behind all these projects. So if you're looking on the Red Hat supported side of things, you have everything from the website, which is JBoss Web Server, JBoss Enterprise Application Platform, Red Hat Single Sign-On, Red Hat Data Grid, and then finally the two different flavors of Red Hat AMQ, Broker and Streams. So this is basically a nice little technology product chart. Just kind of talks about all the different components that our team currently looks at managing and providing solutions for. So we do take a very community-first driven approach. We're here at a community conference, so we want to hear from the community. We want to work with the community, so we're not running in a silo. We have everything out there in the open. We have everything from our source code repositories, which allow you to not only look at the code that we have available for our automation solution, but contribute. We have a consumable, so it's widely available and open for that one-touch, one-click installation. That 11 lines of Jinja, or of YAML, yeah, you really don't need much more than the primitives that are provided by Ansible out of the box. There's no additional components aside from Ansible core. Then finally, we want to hear from the community on the roadmap. So we want to hear feature enhancements, bugs. So we want to gain those and get that information out there. So we really want to hear from you what's working well, what's not working well for the solutions that we're putting together. So how do you get started with Ansible middleware? First, start with the source. Because how many of us here are developers, or at least say we're developers? How many of you probably would have gone to if I were to put a GitHub link out here, how many of you would have either gone to GitHub right after this talk, or since we're all on our mobile devices right now, you might have actually gone to it right now? Raise your hand if you would have potentially done that. So start with the source. First, we have all of our Ansible automation content collections, our documentation, our demos, labs, and feature requests all on GitHub in the GitHub organization and Ansible-middleware. That is the first place I always tell people to look if you are more of a coder. if you want to be able to consume the content, you can go to Ansible Galaxy. This is how you can consume Ansible content collections anywhere. It's a publicly hosted service, very much like Maven Central or PyPy or npm.js. I did not update the link at the bottom. It is not github.com/Ansible middleware. It is the middleware_automation GitHub or Ansible Galaxy. That is my bad. Sorry. Nobody saw that. And finally, I got that link though, right? If you want to look at more of the documentation out there, we have it there too. Check out the docs at ansiblemiddleware.com. And that is, right now, it has basically just our documentation for our content collection. We are relaunching the new website in the next month or two, which is going to be totally refreshed, rebranded, and have a nice look and feel. So you will want to check it out as the project continues to evolve. All right. And of course, try to demo. We have a number of different demos out there that you can look at leveraging. One from those that you build yourself to other entire workshops that you can also look at leveraging. If you were, well, since there were only a few number of people in the workshop yesterday, you could have gotten your hands on trying out Ansible middleware yourself. We'll provide some links later on in the presentation where you can actually spin it up without doing much on your own laptop. You can use Instruct as our platform, so you can do everything and learn about Ansible middleware in your web browser. Our demos provide not only basic capabilities of just getting off the ground, but more complex use cases, multi-product integrations. We're going to show some of that today in our demo shortly, as well as some more advanced capabilities. And then finally, what is the roadmap? What's coming in the Ansible middleware space? So number one, we want to improve the getting started experience. Now, for many of you, this is your first experience in Ansible middleware. We want to make sure that that initial experience is as crisp and seamless as possible. Finally, we're looking at enhancing our documentation. We talked about looking at providing a new, refreshed way of our documentation and website. We want to then look more into the integration with OpenShift virtualization. We see that being a nice target because it's kind of a mix between those who are really looking at adopting the new way of working on a container platform, but still need to manage more traditional workloads, ones that do run in VMs. I work in many organizations around the globe, and I'm sorry to say that there is still a world that still runs in VMs and will still always run in VMs for a very long time. How many of you know that most of the time you're using systems that are talking on mainframes still? Most of us took a train or plane today. It's a good chance that all those back-end ticketing systems are running on mainframes still, or at least parts of it. I definitely know that Amadeus, that it runs most of the airlines out here in Europe, is running on mainframes still.
A few years ago, I had to patch OpenSSH to be able to use Ansible against the AAX in a bank, just to make an example of that.
Isn't that fun? It's still there. And finally, since we do focus very much on our Red Hat customers, we want to ensure that we have a great Red Hat customer experience for those who are looking at getting support at scale in an enterprise supported way. So looking at providing certified and supported content for all the different distribution channels that we look at providing. Okay, I'm turning this over to Guido. I've talked enough. Now, I know Guido. Oh, you're going to, okay, want me to down? Okay. He's just going to do the demo, I guess. Okay, we're going to go ahead and we're going to show Ansible and Red Hat middleware in the wild with a very complex demo. We're going to show how we can push technologies to the edge by using a multi-product use case to make and define highly available environments. We're going to go ahead and spin this up in multiple clouds in the public cloud. We decided to not go ahead and tempt our luck and do cloud and edge for this demo because you never know with things. So this is just a multi-cloud demo. We're going to use Ansible Automation Platform to be able to roll this out at scale. And most importantly, while yes, we've got the initial installation and configuration, but after it's already running, how do you know it's still running? How do you know it's still maintainable? Well, guess what? It's fully observable as well. So we use a lot of monitoring and observability tools to show you how you can then not only stand that up, but use our tools to be able to manage and monitor itself. And finally, every environment that we are deploying is going to look at the following. So we consist of an intelligent load balancer based on JBCS. What does that stand for?
JBoss Core Services.
JBus Core Services. Wow, there we go. See? JBus Core Services. Yeah, basically Apache. A JEE application server, a single sign-on server for providing identity for not only the environment but also the application that we deploy. It has 2 cache instances for highly available single sign-on and 2 database instances. And it takes into account everything from things that our cloud provider will provide, everything from virtual networks, public and private subnets, state replication, failover, crossover, and multiple regions and peering and connectivity between those. All of those is fully automated. It's kind of scary when you think about it. That's some of the power of Ansible that it can provide. Cool. So before we get into the demo, I'd like to just share some resources because a lot of what we have will be cool to talk about after the demo. So I want to put this out here. If you want to learn more about Ansible middleware, go to our GitHub organization, github.com/Ansible middleware. Go to Ansible Galaxy, where you can look at our Ansible content collections. This is the correct link for that. So if you want to jot that down from the link from before, you can do that. We have the Ansible middleware website, ansiblemiddleware.com. Our Red Hat certified content collections are on Automation Hub. And finally, if you want to get in touch with us, ansible-middleware-core@redhat.com. Guido, it's your time to shine. Time for the demo. Yeah.
Let's go back to this a second. Yeah, of course, an infrastructure like this requires a bit more than Ansible collection for middleware. So in this case, we are using managed resources in AWS and in Azure. Both AWS and Azure provide Ansible collections for generating resources, and we provide a repository of code, if you want, or YAML and Jinja that reuses the third-party collection to make the resources, including this part, which is the important part that allows different clouds to give the abstraction for adjacent networks, which allows us, with the middleware collection, to generate clusters configuration. Like this caching service is composed by a cluster in a region, another cluster in another region of the same cloud, another cluster in a first region of Azure, and another cluster in the fourth region. And then all together they form an additional cluster on top of that, the configuration of which is fully controlled by the variable you provide as parameters to the data grid collection and the host names you use to run Ansible against it. And I will show you quickly how it works. Yes. I don't have a pointer. I have a pointer. This window last year ago. Okay. So this is an instance of Ansible Automation Platform Controller, which is a product of Red Hat, which gives an abstraction wrapping up the Ansible command line. It's both an API and a web UI. In the first case, it allows to integrate Ansible as a process in a pipeline or in a workflow, so it can be an integral part of every CI/CD you might have, and can turn to be useful both for testing and also for staging and deploying production environments. And it also provides an UI which makes the first deployment more comfortable, in particular for people that are not so comfortable on the command line. And at the same time provides some additional features on top of Ansible workflows, namely the ability to auto-synchronize the state of the project and jobs inside the UI with the backend SCM repository, which in turn allows to trust that repository as the proper single source of truth for the live deployment you will be executing via Ansible. It's an extremely important concept. If you repeatedly are able to run your Ansible deployment against an environment, Ansible is made so it reports changes only when the found configuration is not what you expect. And what you expect is what you define in your Git repository. Reversely, it would report changes when a commit has been made in the Git repository. The third option is an unexpected change. It is something that you would look for to see what happened. While Ansible reports so, it is proactively fixing it, applying the change, thus turning the configuration to the expected one, meaning the code in the source code repository is the source of truth of what is live. It's an absolute beautiful, easy way for Ansible to solve a complex problem, which other automation tools, they don't even tackle.
Sure.
Let's go to the demo. So for an environment like that, we have a number of, this one, yeah. A number of groups, which are collection of hosts. Any host can belong to multiple groups. Like one random EC2 machines could be in a region and be assigned a service role, like single sign-on or JBCS, be part of Site 1. And we have the hosts, which will be a long list, belonging to those groups. These are the hosts against which we launch a job. We have really two jobs for this project. One creates all the infrastructure, all the cloud resources we have seen in the diagram earlier, and the other one is meant to run the full deployment. Now the system is up. We are launching this job.
We did a little bit of a cooking show, so some of it is already running. We're just going ahead and enforcing configuration as part of this.
Yeah. Going from zero to everything with a project like this is something that, I won't lie to you, would take 35 minutes, which is not long.
No, because it spans up the entire cloud resources and then installs and configures everything. All we're doing right now is just enforcing state, ensuring the deployments are as we see fit. One of the benefits of Ansible is that ID potency being able to ensure drift configuration doesn't occur.
And we take a lot of care that all of our collections are 100% idempotent, because, you know, reporting one change or 10 is the same. The good part is reporting 0 changes when there are 0 changes.
Right.
And that's it. An idempotent run against all those 24 hosts take around 5 minutes.
About 5 minutes. So we have about 6-7 minutes left right now. While it's going ahead and cooking, as they say, are there any questions that we can take in the meantime? Any questions that you may have had regarding any of the content that we've shared, everything from what is Ansible automation, Ansible middleware, what the tools that we provide, what capabilities that you can look at leveraging, whether it be from the edge to the cloud? Any questions? We answered all your questions? Or you just have to sleep? Both are acceptable answers.
That's going. If you are aware of the Instruct tool, we have a workshop available that allows people to experiment with the Ansible collections.
You can get your hands on this without even having to install anything on your laptop. So you get your own Ansible automation platform, you get everything stood up, resources. You basically get to learn how to do a demo similar to this, but see how you can take the role of being not only an administrator of this tool, but also a developer. So you actually get your hands on playing in Visual Studio Code and committing and managing and modifying content. So you get a full hands-on experience of learning not only what Ansible middleware can provide, but some of the different ways you can look at configuring it.
And it is worth mentioning validated content. We are working with a validated content team so that a consumer of our middleware collection will be turned in another collection and provide a pre-baked good scenario installation for instance, services like single sign-on or caching.
Yeah, so the validated content team under the Ansible business unit is looking at providing more validated and not just certified. I wouldn't say I think it's certified from their team. Different demonstrations and use cases that has been known to have gone through the rigor of Red Hat testing and conformance. And the good news is this is almost done. In the 4 minutes we can do it.
Yeah, but close.
Almost. While it's doing that, do you want to just kind of show different configurations inside an automation platform?
Yeah, we are on EAP. Right here, we see it's downloading, it would download the patch version 7.9 to apply to EAP. Actually, it doesn't because it's already patched. And the patch is already there. It does some checking to understand what is available, and it also calls the clean to see what JBoss returns.
We also, one of the cool things that our team did is partner with different teams within Red Hat to establish a new API for downloading content from Red Hat Customer Portal. Downloading content from middleware runtimes had been very challenging in the past. There's now a fully available API that you can not only query for available versions, but also download content directly. So it's really cool. Now using more SSO-based flows.
I wanted to mention that the reason for which it installs at least version 7.4.9 in EAP, it's because that version has a nice technology preview feature, which is the YAML configuration extension, which allows to provide declarative configuration to the bootstrap phase of JBoss, turning JBoss into something configurable.
Yeah, before JBoss configuration was a little more manual. You could script it up to an extent, but now, with, as Guido mentioned, the YAML configuration and tech preview, you can do so in more of a declarative fashion. So it aligns up very nicely with what our team, tooling and automation provides.
So basically, you don't need to query the state at runtime of JBoss to check its configuration. You can move that in the bootstrap phase. Of course, then you don't use the CLI much anymore.
It's a good thing.
It's a very good thing because you can trust what is the configuration without checking it. Remember the Schrödinger cut.
The CLI is good for like runtime configuration.
Please.
Are we able to see the application to roll out? It did. Great. As you see there, we are successful. Let's go and pop up the application. Guido, can we do that? Let's show them something in the 2 minutes. No. Almost. Ansible Fest. Is that it? Yes, it is. It's a simple address book, all integrated with single sign-on when we established it via Ansible automation. And all we need to do is use flange user. We have a bit of a joke. Remember Ansible middleware is helping address the plumbing of your middleware portfolio. So we have that. It then goes ahead and validates the user against it. The automation stood up the Keycloak extension for JBoss EAP, so you can now integrate single sign-on into your applications, and we're able to manage that. This is, once again, highly available, highly scalable. So if we decided to kick off one of our regions, which we've done in the past, it still works.
Let's go through it, because we have these 2 minutes. So what we did, opening that page, is doing a query to the Route 53 DNS of AWS, being latency checked to see which region is the closest to us. The DNS forwarded us to the closer geographically HTTPD, which reverse proxied our request to EAP, which has a WAR file deployed in it, which is configured for single sign-on. So we were redirected in the browser to single sign-on, which has a database down here in this cluster, picks our user, validates our authentication, we are redirected back to EAP, and we see the HTML page.
For a simple HTML page, there's a lot that we're putting out, out under the covers, and that's just all automated through the power of Ansible middleware. We thank you all for joining us this morning. I know it's always hard getting up for the first session after the party, but thank you very much. I appreciate it, and we're here to answer any questions that you have. Thanks, everyone.
Thanks.
to mention some community and release management stuff in the beginning, and then talk a bit about various features. And I try to build some coherent story to this middle part, but actually it's like a fully connected graph that everything matters for something else. We keep producing releases. It's not a steady pace. We try to make releases every 2 or 3 months, and we fail at this every once in a while. When I was preparing those slides, we were still planning to make a release in June, July, but we still haven't produced RC1 for version 254. And we are already at 2,500 patches, and usually we merge another 1,000 to 2,000 before, between the time when we try preparing for RC1 and the final release, so it will be a huge release. And I don't know, I still hope for an RC1 in early July. The number of contributors varies, but it's not going down visibly. An interesting development is that we have more and more stable releases. So we release, for example, 253, and then backport some patches to 253.1.2. We are currently at 253.5, and we are currently at, I think, 251.16 or something like that. So, it's usually hundreds of patches backported to those stable releases, and more distros are using those point releases to build their packages, and there's quite a bit of demand for them. If we keep up current pace for this year, we'll have 44 point releases between various branches. And if you have some patch that you think should land in a stable release, you can either mark it as needs stable backport in the upstream GitHub repository, or you can file a pull request against the stable systemd stable repo with a backport. Just do make sure to use git commit -x to get the hash of the original patch, or sometimes it's enough to make a comment if you cannot do the other things in a pull request. And we have about 2,000 open issues, and it is growing, but in a manageable way. We actually have, I think we close about 80% of issues that are opened. So this is just the diff. And there's a split half and half between bugs and RFEs. We would like to make this number go down, but it's proving tough. But at least it's not bad news. In Fedora, we made an effort over the last year. So those numbers are for, the growth numbers are for a period of approximately last year. In Fedora, we made an effort to reduce the number of open bugs. And in particular, David Tardon and I have been working on going through the bugs and closing some stuff. And I think like this reduction of 50%, it's pretty nice. We don't see that often. And now let me talk about features and being removed first and added later. So this has been going on for the last 10 years approximately, but there are those two related ideas that you have something called unmerged user. The naming is terrible, right? That you have separate hierarchies of bin and user bin, and lib and user lib, and so on for every other possible directory. And you look in both places. And if you have that, you have the other thing called split user, where you delay the mounting of the second half until late in boot. And most distributions have stopped doing that. So Fedora did that maybe 12 years ago. Other distributions maybe a bit later. But the point is that we have been maintaining this split, the unmerged user thing, in systemd code all the time. And it's, well, if you don't have this, then this doesn't make any sense because you have parallel directories, but you always use both. So this and, I mean, both things are going away. Apache is ready in systemd upstream that removes all this code. We will probably measure it a bit later after 254 has been released, just to make the release of 254 faster. Another thing that is going away is support for cgroups v1. This is a more complex problem, but the way that systemd works is that you specify settings in the language of cgroup v2, and systemd will translate the settings to as much as possible for v1 if you're using v1, but this translation is not always possible in any meaningful way, and v1 is not hierarchical, so you cannot do unprivileged delegation because if you delegate stuff on v1, the delegatee can take more than the parent has, so it's not very useful. And some features are missing on v1, so we want to get rid of this and simplify our code base quite a bit, so sometime next year. This is a bit, so if you are using Fedora, like there was a time where this warning popped up in various places, so systemd tools are being unhappy when they are called in a system without /proc mounted. And this is, I mean, the code continues, but it doesn't like the situation. And why are we making this warning? So we need access to proc self-fd symlinks to work with file system descriptors. And without /proc, we don't have this kernel API, and we cannot do various things with file descriptors that we would like to do. Okay, and now about some positive stuff. So we had this issue that users were reporting that when they use user units, they specify some settings, and those settings have no effect. And this is because systemd in general works this way, that if you have settings for system units, and those settings cannot be applied because the system doesn't have the right architecture, or doesn't have, or something was compiled without the right capabilities, settings are ignored. So, I mean, you can, for example, specify both SLLinux and AppArmor policy for a unit, and the one that can be applied on a given system, or maybe none of them would be applied, the other one would be just ignored. And this meant that you could specify some settings, like, I don't know, protect home for a system unit, and it would work. You would specify it for a user unit, and it would be silently ignored because the user manager does not have enough privileges to apply the setting. It could have the privileges if it used a user namespace for the unit, but this wasn't on, and you had to apply this explicitly. So this is something of a compat break, but we are enabling it because there were many reports of people being negatively surprised, and we'll just enable private users in many more cases now, so there will be more sandboxing for user units. And in general, the number of various sandboxing options is growing all the time. I mean, it will probably be a separate talk to talk about them. There is a very nice tool called Analyze Security. Actually, there's two. There is Analyze Security that will give you hints about security settings, and there is systemd Analyze Verify, which will check the unit file for correctness and give warnings if something is wrong. They are both useful for hints and for checking. A small thing, but useful, is open file setting. So quite often, units would use a shell just to redirect some file descriptor to some file from some file. This can be done now natively by the manager. And of course, the advantage is that things are simplified, and also that the unit can run sometimes with less privileges because it can get access to a file as a file descriptor and not be able to open the file otherwise. We have a new unit type. So type equals notify is an old thing. So it's a when units are started, the unit systemd likes to make this operation synchronous. So it wants to know when the unit is actually ready. And in type equals notify, the unit runs and sends a notification message using the SD notify protocol when it's ready. And for reloads, we usually use, the easiest option for reload is just to let systemd send a SIG-hub signal to the unit. But this is asynchronous. The signal by definition is without any communication in the other way. So with type equals notify reload, the unit is supposed to send a SD notify notification after a reload has been finished. So we get a convenient implementation of reloads with synchronicity. So readiness notification. Another feature, it gets a separate slide because I think it's pretty nice, is soft reboot. So it's it's a new way to restart the machine that brings down all the user space, unmounts things, and instead of actually rebooting, restarts, re-execs systemd and brings up the user space again. So, so we have like a normal reboot which goes through the bootloader and the new kernel. We have kexec which just skips the bootloader and goes directly to a new kernel. And now we have soft reboot which skips both of those steps and goes directly to a new systemd. Another feature, this one even gets an icon, is the I/O cost controller. So actually this is a kernel feature mostly, and this is quite common in systemd stuff that we are just providing a thin layer around the kernel. When you have a block device, you get some number that it has some bandwidth, I don't know, 500 megabytes per second read speed or write speed. And we know this is not true in general because the actual bandwidth depends on what the device is doing and how much writing you are doing at the same time. So initially you specify some blocks to write, and it is very quick because it actually goes to some internal buffer. And then things slow down quite a bit, and depending whether you are reading at the same time, the write speed will vary and so on. So the idea is to do fairly extensive benchmarking of a specific model of a drive, come up with a simplified model that describes how the drive behaves under various conditions, and then you can set a meaningful policy to divide the bandwidth between services and groups and so on. And where systemd comes in is that this is implemented in the kernel, but we need to provide the policy. And systemd now has a UDEF rules to figure out what policy to set for a drive based on the model, firmware revision, and so on. And in the hardware database, we are starting to grow a set of rules for different drive models. So if you have a drive model that is missing, you can do the benchmarking and submit a pull request, and then it will be applied to all the drives in, well, wherever people are using this. So this was actually contributed by Facebook folks. And now some sub features, and here sub stands for subterranean. Those are large features, they're just not very visible. And so this is another kernel thing. When we use process numbers, PIDs, to refer to processes, it is well known that a process can die, we wait a bit, and another process gets born, and it gets the same number. So PIDs are not a reliable way to refer to processes. And the kernel has gained APIs to refer to processing using file descriptors, PDFDs. So this ambiguity goes away, and various systemd tools have been converted to use PDFDs internally, and also stuff like libsystemd and the dbus APIs are getting extended with a second set of calls that allow PDFDs to be used instead of PIDs. So this is quite a bit of work, but it's generally not visible if it works. And kind of in a similar vein, internally we are converting a lot of our code to use file descriptors to refer to inodes instead of the path name. The most obvious thing is that this allows, removes the possibility of a check time of use race between, I don't know, checking the file and executing the file. But also it makes it easier to write code which operates on subtrees of the file system hierarchy, so change roots, and also disk images that you mount temporarily somewhere, and then you do an operation on the on this image. And I also wanted to mention kernel install. It was rewritten in C. It used to be a bash script, and this meant that, well, first of all logic had to be implemented, like, for example, to find where the ESP is, which is actually a very complex game of guessing, had to be duplicated and this was very annoying. So in the end, E. Watanabe rewrote it, and it also means that we can use FDs in kernel install, and kernel install will now operate fairly nicely on, you can say kernel install -- image equals image name, and then do an installation on the inside of a disk image. I mean, I think not yet, but soon. And so this brings me to disk images. So the idea has been around for a while, but the name is new. So discoverable disk image is an image a disk image that, or an actual disk that follows the discoverable partition specification. So it has a GPT table, and in the GPT table, the role that the different partitions should be used for is specified by their partition type identifier, and you don't need other configuration. Systemd dissect has been around for a while, but it has grown new capabilities. So, for example, it can you give an image, and it can recursively mount the image on some mount point. And the mounting is done in the same way that if you booted the image and you would auto-discover that, I don't know, like /var, a specific partition is /var, and another partition is /home based on the DPS. People talk about supply chain issues, so a bit in this topic, the M3 command makes like a recursive report of the contents of an image. And this is a systemd dissect example. I try to make it fit on a slide, so this is like, you know, after surgery. So it opens the image and extracts the OS3 file, so it knows what the image thinks about itself, and prints some metadata and partition list. But it also has this idea of using the same image for different things. So this is where the DDI power is. So this particular image can be booted in UEFI, so as a real system, or in QEMU. It can be used as a container, but it's not suitable for the other things. And so we have portable services, so a service that is like a normal system service but comes with its own file system, an initRD, and a DDI can also be an extension for each of those things above. So we have the same format, but depending on what partitions are inside and some metadata, it is used in different ways. And this area in general there have been a lot of development in systemd with capabilities for this. In particular, how to apply the extensions in various places, and how to check that the extensions are assigned properly. I have a second talk in the afternoon where I talk more about this, because it's just not enough time here. But briefly, so we have extensions that allow us to add stuff to an image. For example, we have an immutable image that is signed, we boot it, and we want to extend it, and we have those extensions that can also be immutable and signed. But there are also other mechanisms. So a lot of work has been going into credentials. So credentials are this systemd idea that you have a blob of data. For example, it could be some configuration snippet or a certificate file. And the manager will take this blob, and when it is starting, it's stored somewhere. And when it is starting a service, the service specifies that it wants a specific credential. The manager finds this credential and creates a file before the service is started, and then the service can load the file. So this doesn't sound useful, but the thing is that this storage can vary a lot. So it can be a file on disk, and the credential can be also encrypted, and then systemd will decrypt the credential before passing it to the service. It can come from a pipe or a socket. So this means that credentials can be generated dynamically when requested, and they can be stored in QEMU, SMBIOS fields, and some other similar stuff, which means that you can pass a credential to a virtual machine. They can be specified on the kernel command line. The bootloader will load them from, SDBoot will load them from /ESP, from the ESP partition. And credentials are hierarchical in the sense that we can have a situation where we have a credential on disk. This is passed to the virtual machine manager, and then this passes it to the virtual machine, and the virtual machine passes it to, well, a systemd in the virtual machine loads it and passes it to a service, and so on, right? And an example of how this is, how we make use of this is there's this specific credential called VMM notify socket, and we put a VM, we pass the credential to the to QEMU, and inside of the machine, system deboots and sees that it has a credential. It looks for a credential by this name, and sends notification to this socket. So, for example, it sends ready equals 1 when it has finished booting. So this allows us to cross the boundary between the host and the machine, and this is done in a fairly nice way. There is no network involved. It's a fairly generic mechanism, so also it can send an exit status notification. So basically, you can have the situation where you make the virtual machine and the container behave in the same way, and you can specify an exit status and have the machine fail. For example, very nice for unit tests, where you do some tests in a virtual machine or in a container or both, and you want to have this uniform. Another tool that has seen significant work is systemd measure. So the idea is that you build a new kernel, and before you boot the kernel, you build a kernel and inid and figure out some command line options and stuff like that. And with all that, before you boot it, you calculate what PCR values will be, what the PCR values will be after you have booted this this combination of things. And this means that you can, you can predict those numbers, and it means that you can sign policies for them. So this is all geared towards pre-calculating PCR values and signing policies and encrypting secrets in a way that they're bound to certificates, not specific PCR values. And a related topic is that we have a new idea of boot phase paths. So systemd will write those strings at various points during the boot sequence, which means that the PCR values change at defined points during the boot time. And this means that, for example, you can have a key for the root volume, lux, for the root lux volume that can be bound to the TPM and can only be decrypted in the initRD, because after you have exited from the initRD, the PCRs change and you cannot access the same secret anymore. And so on. And there's also a number of stuff that is services that write information about the machine into various PCRs so that we can build more useful policies. So, for example, like the machine ID and the information about disks that are mounted in various places. And again, this is about building PCR policies that actually are useful. Something that I have been working on is a helper to create unified kernel images. So this is like UKIFI uses systemd measure. So you have a kernel and an initRD and some command line settings, and now you call systemd measure to figure out what PCR values will be. You build a PCR policy, all of this, you sign it, you put it also into the unified kernel image, possibly multiple of those policies, and then you sign this whole combined thing for secure boot with yet another key. So it's quite a bit of messiness, and UKIFI makes this easier. It has been rewritten to, now it does, I mean, systemd measure doesn't require root privileges because it doesn't access the TPM anymore. And so UKIFI also doesn't require root privileges, which is just nicer and faster. Another tool that has seen a lot of work is systemd repart. So it is, you specify a set of partitions that you expect to see on the machine, and when repart is executed, it will match those definitions to the partitions that are on disk and create any that are missing, and maybe, for example, grow the ones that are too small and so on. And if everything matches, then it's just an idempotent operation. So repart is nice because it works atomically. So it first opens a device without having a partition in the partition table, goes to a specific offset, writes the contents, and after this has been done, syncs the disk, and then creates a partition entry at the beginning of the disk. So the partition appears with contents, I mean with a file system and files in the file system if you specify so already at once. And we used to do it in this way that we would use a loopback device to mount a temporary partition somewhere. But now the code has been reworked to use file system tools to write the file system contents, including files, directly at a specific offset. And this doesn't require root privileges, so you can build file system images inside of a container, and then also as an unprivileged user. And it's also faster. It's nice. There has been also quite a bit of work on the systemd bootloader and the systemd stub. So systemd boot is the bootloader for UEFI, and systemd stub is the thing that is prepended to the kernel to create a unified kernel image. And we used to have a dependency on GNU UEFI. It was quite a lot of code, and it was annoying to have this. We wrote a bunch of stuff to get rid of the dependency, so they are now smaller, and we also like our code better. You can use SD boot for direct kernel boots under QEMU. So you call QEMU -- kernel SD boot, and then SD boot works as a kernel and will actually load another kernel from inside of the image. This has been around for a while, but it's kind of becoming more interesting with the whole work on unified kernel images, that SD boot will do enrollment of secure boot keys if the machine is booted in setup mode. And I also wanted to mention that there's some improvements to pass the random seed to the kernel. So the kernel gets started, already has the random pool populated, so we don't need to delay waiting for randomness. This used to be a problem, a source of delays in the past. And Anaconda, the installer used for Fedora and RHEL systems, is getting support for system deboot. So this pull request has been merged. It's not complete yet, but hopefully we will be able to install systems using sdeboot fairly soon. And I wanted to mention that we don't bite, and you know, like there are issues and stuff to work on, and we merge pull requests quite often, and I will be happy to see more contributors. And yeah, so 4 minutes for questions. Sorry, I didn't catch this.
Soft reboot, system-based soft reboot, would that work with OS3 systems?
So the question was whether soft reboot will work with OS3 systems. I don't think there's any reason why not. I mean, what it does, after it has brought the user space down, it calls the equivalent of like a switch root operation, and you specify a new systemd binary and potentially some options. So we can figure out a way to boot OS3, the same one or a different one.
So you would still be using the same kernel?
Yes, the same kernel, yes. And actually, processes can survive. I mean, you can mark processes not to be killed, so it's not a complete replacement. Okay, so. Thanks. Thank you.
I'm so tired. Haven't gotten any sleep.
Hello, let's welcome Eric Gustafsson, my dear colleague. This talk is going to be about conversions,
that's good.
distributions. The floor is yours.
Perfect timing. Why is this not working now? Because of course the computer has to lock itself just as I'm about to start. But yeah, I can start a bit. I'm Eric. I'm the team lead for now, the team lead of Convert2Rel, which is managing a product called Convert2Rel. It's a team of 7, something like that, and God, this is frustrating. There we go. All right. So I'm going to be talking about how you can convert a system, right? And it's going to be primarily about CentOS. So most of the systems that are similar to CentOS are based off of RHEL. So you have Alma, you have Rocky, you have Oracle Linux, CentOS as well. CentOS Stream is actually upstream, so it doesn't really count, but that's what RHEL is based off of. So that's why it makes it quite easy to convert. So you have relatively simple process, everything's basically the same. But when it comes to something like Debian, it's a lot more difficult because then you have to deal with a completely different architecture and ground, right? Because they're not similar in that way. But converting is still difficult in a way. The actual process is easy, but there's always going to be some edge cases and other difficulties. So there's a few tools that people have developed over time. I don't think Convert2Rel was the first one. I think that was actually CentOS to Oracle Linux, if I'm not correct, but yeah. There's a few tools though. There's Elevate, which allows you to upgrade systems, so from CentOS going to Alma, some of that. They also have an Alma Linux deploy, which is actually converting from CentOS or CentOS Stream over to Alma. For Oracle, there's CentOS to Oracle, and that's, they're a bit simpler. We have Convert2Rel, which is a relatively big product, which converts you to RHEL, and then for Rocky, you have Migrate to Rocky. So there's a few tools available. Anyway, so I'm from the North Pole. I come from Sweden. I'm currently making some kombucha. I'm trying to learn piano. I tried to do some mountain biking when I was living here in Brno, but now it's very flat where I am, so I have to go quite a bit to get somewhere. I've been a developer for 5 years. Started at a front-end kind of environment where I was mostly working by myself, but I learned a lot. And then I think since 2-3 years ago, I started with Python and actually developing Convert2Rel. And being the team lead, it's something I'm going to transition over because I can't really be a manager as well as being a team lead, but And I'm also a crazy cat lady because I have some cats, right? There's Isolde on the left side, and then you have Lisa on the right, both Maine Coons. They're going to be quite big. Oh, and Mimi Samoose as well. So, what are the differences between the tools? Well, first off, converting a system, why would you even want to do that, right? You can just redeploy, and in most cases, I would say redeploy is probably the better option because when you redeploy, you get a fresh system. You're not going to have any weird things that you didn't think of before. When you convert a system, you're gonna have something, even if you don't know what, you're gonna have something that is still from the old system. So if you convert from CentOS to Alma, there's gonna be some CentOS parts, right? But you're not really having any redeployments when you're converting place. There's gonna be all the configurations and files, and then when you have converted over, you know what you haven't converted with the packages at least. So there's some security there. And I would say most of the time, it still makes sense to redeploy, but if you can't redeploy, then converting in place is the way to go. And for redeployments, it's probably the better option, right? You have better safety margin if you can. Everything, you can make sure everything is working. You can have stage migration, so you can keep the old systems running while you're redeploying the new ones, and then after a while you shut it off, right? And that's usually what bigger companies do, right? I think Facebook did it where they went from RHEL to CentOS Stream, they also had like gradual staging migrations. So the differences, I don't know, maybe it's going to be a bit heated, but yeah, I think Convert to RHEL focuses a bit more on like stability and testing. So a lot of the tools have a lot of lines of code, but I think the Convert to RHEL is probably the biggest project out there so far. If we exclude Elevate, which is kind of Leap, which is RHEL upgrades, but I'll get to that soon. And then Elevate, which is a play on enterprise Linux, which is why they have EL capitalized. They kind of treat CentOS 7 as like an upgrade path, so they disregard that it's CentOS altogether and just say, yeah, well, it's similar, so we can just upgrade it to Alma, to Rocky, to CentOS Stream, anything like that. And then Alma Linux deploy CentOS to Oracle and migrate to Rocky. They're basically just a bash script, so they're automating the tedious parts, but there's gonna be some manual steps to like fix things. So the general execution flow of like converting a system is kind of easy, right? I mentioned that before. You just have to clear the cache, you have to update the package to the latest version to make sure that you're on the latest at least. You change the repository to the new version or a new distro by keeping the same major version. So if you're on CentOS 7 and you want to go to RHEL 7, then keep the same major version. You don't go to CentOS 7 to RHEL 8. Because it's more complexity, so it's more difficult to know what's going on. And then you just replace the packages with their new distro repo counterparts, right? So if you have Apache on CentOS repos, you just reinstall that, so it's now pointing to, it is now the package from RHEL. And that's it. That's the whole process of converting. Talk over, right? But there's always edge cases, like UEFI is one of them, where like on CentOS, there are some edge cases that doesn't really work when you just try to install a new kernel and so on. You have different custom scenarios where like if you're doing something with your company, there might be some things there that you will have to work around. Bad packages, which is more of like, well, for example, CentOS logos is one of them, right? That's very CentOS specific, so you want to like have to try and mitigate that somehow, right? And then package dependency mismatches, etc. The package dependency mismatch is probably the biggest issue, I would say. Like there will be something, and a lot of the tools try to just like, oh well, either we just ignore it if it doesn't work, or we try to mitigate it somehow, or just like say fix it before you convert, depending on the tool. So. Yeah, there's endless configurations, right? Every system is going to be unique. There's going to be packages that don't work, right? For example, mod LDAP is one of the packages that you can see on the right side that just does not work when you try to convert it from CentOS to RHEL because there's some dependency things that they can't really resolve. So those things we kind of have to ignore. And then it's in general easier to convert to Alma and Rocky from CentOS than, for example, from CentOS to RHEL, because they are, I mean, there's a successor to CentOS, so they have some, like, they're pretty much similar. I would say it's almost the same system. So it just makes it easier, but RHEL actually packages their own systems or packages, and then it makes it a bit easier to convert to Alma and Rocky. And then CentOS Stream, that's like the big scary one, because CentOS Stream, since it's an upstream from RHEL, there's going to be downgrades when you go from CentOS Stream to RHEL or something else, because you have so many different downgrades. So either you just freeze it in place for a long while, which is not secure and not something you should do, and then you just hope for the best. But it's still a scary subject to like try to do it yourself. And the reason for that is like that you're going to have downgrades, and they're not usually tested. So package maintainers, they usually test that upgrading a package is fine, but when it comes to downgrading, they don't usually do that, which in general, it's not going to cause an issue, but if, let's say, a package updates some configuration file, like a format or something, then they can't really go back to that previous format. So let's delve into some more facts about how to actually do it. Yeah, as I mentioned, it's all based off of RHEL, which is in turn based off, well, it's based off of CentOS Stream, which is based on Fedora, right? But almost the same thing. Packages are mostly fine when upgrading, since it's, it's tested, you have like some security there. I don't think it's going to be an issue if you go from CentOS to RHEL, CentOS to Alma, and I have to upgrade it because the version difference, it kind of works out. But the downgrades, we just don't know. We can never tell. It's like, okay, we have to try, see what breaks. If nothing breaks, it's probably fine. And as mentioned, they don't usually test that downgrades work. But CentOS Stream is still something that you can convert. There are some tools that allow it. Unbounded Deploy has an option for it, where if you put in -- downgrade, I think, then you will be able to convert CentOS Stream. And then Convert to RHEL is trying to do it as well, but since we're trying to do resilience and make sure everything is going as smoothly, we have a semi-working draft that's been up for quite a while. But it's such a big topic that we have not really tackled like how we should actually do it yet. And then configuration migrations, they will happen. They can't really be reversed. Like when you have a breaking change for a configuration file, yeah, you're probably going to have to fix it manually. At least that's what I believe, right? Or just talk to the package maintainer and see if they actually have some script that you can just reverse engineer, maybe. So bootloader is another thing that's a bit edge casey. So bootloader, if you don't know, you just have a bunch of options. It has an order to go through for the booting. And this is from my machine, so I'm running a Fedora Silverblue, or well, Kinoite, which is KDE. For some reason I see RHEL there, but I don't know why, because it's a Fedora machine. But it's booting from Fedora. If you're trying to convert this to something else, you would change the boot order, you would add a new entry, and it would show a different file. And that may cause some issues in some systems, as I mentioned, right? Secure boot is another thing that will not work when you convert, because secure boot wants things to stay as they are. You should not modify things, right? So you kind of have to turn that off when you're converting. And then for CentOS 7, there will be some edge cases if you're using UEFI, because when we're creating a new system, converting to RHEL, for example, when we're creating a new boot order, it's not really going to work. Because there's going to be a difference with the actual, well, let me go back. In the actual file path, there's going to be an issue. Because we're not going to be pointing to the correct files. We have to fix it manually and create our own entry. And then you may be naive in thinking, okay, well, I can use ls-blk to get all the block devices, and then I see the miner thing there, and then it's going to be the miner number that I use, so I can just use that and do it automated. Which we thought worked until we got some customer complaints that it doesn't work. And as you can see in the lower picture, you can see that it says SDI1, which is the first partition of SDI. But the miner version, or the miner block number, is 129, which is not the partition number. So getting that was actually quite difficult. In the end, we managed to find with this command here, blkid, and we just get the part entry number from there, and that actually worked. And another thing that I don't think anyone on our team realized, that boot number entries, they're actually hexadecimal. So you can get something that says boot 001A, and that's just going to break everything you just automated. It's assuming it's all numbers, because why would you need 9,999 configurations, right? I mean, I don't think I've ever seen that. So, but they use hexadecimal, so that's why I have to think that's an edge case. And then with the actual tools, I mean, there's going to be more variants, right? You have the normal AMD Intel x86, which is the easy part. You have Arch, which is which is getting up into popularity, because it's usually a bit better than x86 in a lot of regards. You have IBM Power Systems. You have different major and minor versions. And then you have different life cycles on non-minor versions and major versions, right? So you have long-term support or extended upgrade support, I think that was stands for, something like that. And that means even more packages to test. So if you want to make sure things are good, then you have to go through. The best way to test is just converter, right? You can just convert a test system, or spin up a mirror and try to convert that and see if anything breaks. But there will be some package-specific or architecture-specific versions for each package, unless they're using NoArch, which works on everything. If they have a Python package, then as long as the system can have Python, it should work. So it's just NoArch. or no Arch, maybe. And then kernel packages. I haven't looked into this, but I assume that kernel packages are going to be different on like ARM versus x86. So that's another thing, because packages from kernel is going to be, I mean, that's the most important part, right? Because when you're converting, you want to make sure that the kernel is actually from the new repository, the new distribution. So that's one of the things. And then if we want to make it more complicated, we have cloud conversions, right? So for subscription-based services like Oracle Linux or RHEL, they have like two options. You have bring your own subscription, BYOS, and pay as you go. And BYOS is like images that the cloud providers provide, and then pay as you go is like, well, you don't pay for the subscription right away, you pay for the usage, so it's like added on top of the hourly rate that machines have, or like the minute rate. BYOS is similar, like it's similar to the normal conversion. It's going to be quite easy. Everything should work as normal. There might be some subscription issues, but in general, it shouldn't be. And then PayG, that one is a bit more of a difficult thing, because actual cloud providers, they hook the billing to the actual machine. So when you're converting that from Oracle over to RHEL, for example, you're going to get double billed. So you're going to get a bill from Oracle, and you're going to get a bill from Red Hat, which it's not ideal, and the cloud providers are trying to solve that. I know AWS, I think AWS is the one. They're trying to fix this somehow. And then there can also be slight differences in ISOs provided by cloud providers. I think that Google, they provide their own CentOS Linux builds because they want to package their own, they want to introduce something. And then AWS, they actually use security hardened images from a third party that's partnered with AWS. And without knowing like the difference between these and like the actual images from the official repositories, it's difficult to know whether it will pass or not, right? So you have to test that as well. And then you have like normal images from like non-enterprise Linux, like Alma, Rocky, so on. Like all of those should be available, and you can just convert. And we kind of treat them as like a normal conversion because that's usually the easier part. But the enterprise ones are more difficult. Oh, and actually testing the conversions. I mean, this is a big topic. Every OS, every architecture, every version is different. So it's going to be a huge test suite of all kinds of different environments. We want to stay as close to the environment of the tool that you're trying to run. So if you're converting CentOS 7 that's using some IDM server, you kind of want to reproduce that in a test environment first and then see if it converts. Ideally, you just want to like spin up a backup and then see, okay, can I convert? If not, then something needs to be changed, right? Containers, they are actually great for converting. I know that Elevate is actually going into some boot management options, so container doesn't really work there because they spin up an init ROM FS in kind of boot entry where it finishes the conversion in, and that doesn't really work with containers. Correct me if I'm wrong, Peter, but I assume you don't really run it in containers, right? So, but most of the time you can use unit tests with containers. That's like an easy part. But it's not a good picture. You can just test the actual unit, but it's not going to test like the whole conversion. So you have to actually use VMs or some kind of bare metal machine to try to convert. And I know that Converterel extensively uses it. So we have a whole, we're using testing farm to test a whole array of machines. And then we also have our own VMs. We try to use Vagrant if you want something simple. And we can spin up pretty much any of the systems that Converterel can support. And then you just try to install as many packages as you can. If possible, install all of the packages that are from the distribution, from the repositories, because then you will know if there are any packages that are not going to be converted, if there's any issues, and so on. And ideally, just clone the system, because otherwise it's just going to be, it's not going to be the complete mirror of what you're actually trying to convert. And make sure that you have backups. I didn't put it in here, but backups are like important because if there's an issue and you're into production, and it's like, oh, well, my production system is down. I didn't do a backup. Shit. Then it's kind of ruined, right? And then you have to try and fix the actual machine instead of restoring from backup and so on. So, God, that was so fast. But yeah, so any questions? Because I feel like there's going to be quite a few when it comes to converting. Yeah, Peter?
As you said, that one of the downsides of trying to convert the system from CentOS stream to RHEL is number of downgrades. So what if, for example, I plan that, okay, I would like to convert my system in 6+ months. So now I will accept just security bug fixes that I really have to have for my system, and then I will convert, because based on the logic, I would expect that I will reduce significantly the number of downgrades during the conversion.
Right. So the question is, when you're converting CentOS stream to RHEL and you have to like freeze all the packages, can you just allow security patches to go through? That's basically it. Yeah. I don't think so. I think there's still going to be some issues with the downgrades. I mean, it's going to make the system more secure, right? Because we need some security. But when you're actually converting the system over from something, there will be downgrades. And if it's a security-related package, then you will have to solve it. But it depends on how much resources you have. Like if you have enough resources that you can investigate, okay, this package is going to be an issue. How can we mitigate that? How can we fix it? And you create some custom scripts to like fix that. It's fine. But there might be a lot, and that's not ideal. So you have to try and see. Yeah.
How would you know which is security fix? Because it doesn't publish the route information, so...
Yeah, that's a good question. I know that the DNF has the possibility to set the option that you can apply any security patches.
Yes, but I think it relies on the route. The route isn't there.
You are right. I would have to spend the time on it, I guess. But they will be first on routes, like check errata or urgent CVEs. Of course, most likely there will be some downgrade, but I guess it could be reduce the number.
Yeah. All right. Any questions? All right. I think that's it. You can always reach me afterwards. I'm available on Mastodon as well as on Twitter. It's just Spytech, so you can find me there. And I also go by Gustafsson on Red Hat. So, yeah, thank you. I'm so fast.
I think you were expecting more questions, right?
Okay. Well, time is up, therefore, I would like to welcome all of you on a presentation related to the interesting topic, or controversial topic, modularity. My name is Jaroslav Mráček, and I am from Red Hat and software management team. Well, what I will talk about, well, there will be some introduction, then there will be something related to the how to move modular rules to the RPM, and then it will be follows how to hack modules, and let's talk about how to list alternative software, and what about stream defaults, and at the end, well, there will be the section related to the testing of alternative streams. Well, before we start to talk about modularity and how to move rules about modularity, let's talk about feature of the modularity, because this is sometimes overlooked. Therefore, what is modularity and what it provides? Well, modularity provides virtual repositories with dependencies. And it means these repositories has requires and the conflicts. Also, it allows you to set a different alternative for the alternatives different life cycle. For the some distribution, this is one of the key feature. Therefore, how to deliver software to the users with explicit stating and visible stating, okay, it has a limited life cycle in comparison to the main part of the distribution. Well, another feature is that it allows you to create alternative content without modifying a spec, because it will not change the name of the RPMs. Modularity, it's not required because modularity creates a conflict for you and hides everything what can conflict with your packages. Well, another feature is better user experience with the alternatives. You can easily manage your content because you can list alternatives. You can pick what you want to install, which profiles, and so on. And well, you can also build dependent modules. Therefore, you can build on top of existing modules other content. And the last but not least, well, default software streams. This is quite important because not all features is available for all of your alternatives, but I will talk about this later. Well, here's just a scheme, just a small example. Sorry for maintenance spiral. I just use it as an example name. Well, Perl is distributed in Fedora and in RHEL with alternative versions. Therefore, for the one Perl, yeah, you have several alternative streams, and one of the stream is marked as a default. Therefore, if you install your system, by default, you will start to consume, if you need, this stream. And also, on top of that, you can build dependent modules. In this example is a Perl DBI that could be built for all of the version of the Perls. Modularity, what it does, if you want to install Perl DBI by default, it will automatically pick in the background the default stream. If you want to use alternative, if you already have enabled alternative version, it means, for example, Perl 5.32, then it will automatically pick the right content for your system. Therefore, it's quite easy to use from the user perspective. Well, you know, everything has a price. Let's talk about the price. We said that you don't need to modify specs, therefore, even all alternative Perls still build package called Perl. Therefore, to keep upgrade path, you need to do something with your content. Therefore, first of all, none of the modular rules are written in RPM. Therefore, you need the external metadata that will say, okay, this is part of this stream, this is part of another stream, and so on. Therefore, there is a modular YAML. Okay, but also, as I said, yeah, it needs to hide things that are not related to your system. Therefore, example of the Perl, if you enable or if you have a default, you will only see one stream. the other streams and other content from the other stream is hidden for user. Therefore, it requires modular filtering, and this is implemented in DNF. Also, well, there are some protection layers. Therefore, we know that there are some safety measurements that if you install modular RPM, then, and you don't have a description for this modular RPM in the modular YAML, then DNF will refuse to install it. They will say, okay, well, sorry, I cannot do it because I don't know nothing about this RPM. To resolve all of these relationships, okay, it requires also additional solver, which will say, okay, this content is valid for your system, and I will only provide and show you the valid content for your system. And of course, well, there is a modular build system, therefore the system where you can build these modular alternatives. Well, let's just go with the alternative scenarios. Well, first I would like to say a few things about how to move modular rules to the RPM. And then, well, let's talk about alternative stream without modules and how we can, for example, use the groups to deliver alternative modules. Well, one of the features that I mentioned at the beginning is that, well, you can have one spec to build multiple modules. Therefore, I will try to use an example where you will have a one module spec that will be able to be used for this alternative approach without modifying for the multiple streams. But this is just optional. Yeah, you don't need to use that. You know, many things are optional. That's the problem. Well, in the original spec, well, you only define a name of the package. Again, Perl, sorry. And well, with the alternatives, to ensure that there will be right upgrade path, you should rename package for each stream because you want to ensure that there will be a right upgrade path. Therefore, if, for example, in this example, you will use a Perl and with some suffix, then it's unique name, and if you install this name, it will always keep the right upgrade path for your system, and it will not jump from one alternative stream to another one. Additional thing, yeah, this is just a pre-requirement, but as you can see, well, we start to modify spec. It's not enough, because if you have two different names, and doesn't matter whether inside it uses the string Perl or not, by definition, they are normally installed in parallel. Therefore, if they are not installed, these alternatives in parallel, you have to set up conflicts. Therefore, you have to conflict with Perl because, well, if you will provide Perl, then it will work. Therefore, it will ensure that only one provider of the Perl will be on your system. If you will not do that, you will get again conflict. But after, when the transaction will start to perform, therefore, after you download everything, and then RPM will tell you, you know, there is a file conflict. You cannot do that. It's too late, and people don't like it, and don't do that, please. Well, if you want to achieve that your users will type DNF install Perl, and you want to install any Perl, including with this suffix, therefore, these packages must provide Perl, and this is also a prerequisite for the conflict. And if it's Arc-specific package, you have to also provide the Perl with the ISA macro. Otherwise, you will break other things. Well, all of these things are optional. You have to think, if you add there, you will get a feature. If it's not there, the feature is not there. It's not a requirement. Everything is optional. But some of these are required if you have a conflict with the files. Well, because we would like to move also identifiers of the module, then we can set up some virtual provides. Well, I use some examples, but well, this is just an example of how you can write information using virtual provides. But please be careful, or try to use it as less as possible, because any new virtual provides increase the metadata. Any new provides increase the requirements for the solver, and our distribution is still growing in this direction. Your provides is also growing because no one is stripping these former provides and so on. And it will require more resources, disk, RAM, and so on. Therefore, please be careful. As a package manager, please look what you have in your spec and periodically clean it what is not needed. It's good approach how to sustain or how to maintain our distribution in the right shape. Well, I also mentioned ParallelDBI as a dependent module. Therefore, if I have a package that depends on top of alternative, then I have to specify the build requires. If in this example I use a build requires this package.conf macro. Well, with this stuff, all of your packages will provide package.conf parallel. Therefore, you have to modify it because otherwise you will be unable to pick the right parallel provider. Therefore, if you want to build your package with a certain alternative stream, then you have to modify build require, and you can use these that you specify the full name for the devel package. Well, be careful, this is not according to the guidelines. If you will read the guidelines, they prefer to use the package.conf. But if you provide the alternatives, you have two options. All of them will provide the same macro, or satisfy the same macro, or you will rename it inside your code. It means it's rename of the one file, and again, this is extra work, and this is up to you. This is a definition, or this is option. Well, if we have such a package, if we have these alternatives, well, we can start to think about what we need from the modules. And as I said, yeah, there is a modular filtering. If you rename your packages for each stream and you set up correctly conflicts, you don't need that feature, because upgrade path is ensured from this point by rules inside the RPM. Therefore, you don't need a modular filtering, but you can use it. Now, from this point, it's optional. Why? Because, well, sometimes you don't want to confuse your users by providing thousands and thousands of packages. Therefore, sometimes it's much better to say, okay, well, here's one alternative, and you see all of the packages, and here is the list of alternatives, and you can switch. It's optional. It's up to the end user whether you want to use it or not. And if you want to disable modular filtering and still use modular YAML, then you can specify name of the packages in the section of the demodulars and RPM, and then you will list all of the names of the packages, and then you will see them. Yeah, DNF start to ignore them. Therefore, nothing will be hide from other repositories and from non-modular stuff, but it's usually not needed if you use these compat packages. Well, also, you don't need a fail-safe, because you set up all of the rules into RPM, it's intact, therefore you don't need any additional guarder. How to disable modular fail-safe system for the things that are described in the modular YAML? Easy, don't build them with the modular label. If the modular label is not present in the RPM header, then again the rule is not applied. Well, another topic is default stream. And maybe, well, before, because we are, well, closely to the middle, well, let's try something different. Let's try a small exercise, if you don't mind. Well, let's play a game related to the solver. Yeah, therefore, solver is an algorithm that tries to pick the right version. Therefore, you set rules, and according to the rule, you will get the solution. And let's just say, okay, well, I will ask you a question, and please, according to my prerequisition, please answer. Yeah, therefore, I'm trying to pick a random person. Well, may I ask you for cooperation? Yeah, please, well, pick anyone in this room who is in front of you. Yeah, me. Okay, well, can we repeat it once again? Frank. Yeah, if we will repeat it 100 times, will I get a consistent answer? Yes. Great. Okay, let's try. Anu, okay, one with you. Same question, same rule. Well, will I get pick anyone in the room who is in front of you?
In front of me?
Yes. Thank you. Yeah. Okay, then, and we will test it 1,000 times, we will guess the consequences. Yes, I tested independently in the 2 examples. Yeah, and it works. That's how we test out our, let's say, our theory. Yeah, we set the rules and it works. Well, you know, time is passing. We have a more alternative content, and then I will ask someone from the last line. Okay, oh, they are sleeping. Neil, please pick anyone in the room who is in front of you. Okay, well, try again.
There.
Yeah, okay, and once again.
There.
Okay, that's a regression on the solver, yeah? Yeah, because at the beginning we test that we have consistent results, and we test it well 100 times and multiple into 2 different environments, and it works. Yeah, and that's how it works. Therefore, at the beginning of the distribution, you set your environment. You think about that you have a right approach how to deliver software, and you test it. You set up multiple environments, and it works. Suddenly, after a few years, when more and more version of the software appears, then you get inconsistent reasons. And what happened? Because I tested well, solver is wrong. Yeah, it's regression because I tested and it worked correctly. Yeah, and that's what we have normal reports for our site. Therefore, if you want to set up the distribution, please think about the future. Therefore, if something works right now, even if I test it well, then it doesn't mean that it will work in future because environment change. Our distributions are live organisms. Therefore, they evolve. They are moving from the one state to another state, but you are unable to change the rules. Rules are usually fixed, baked, unchangeable, and you have to live with that. Therefore, thank you very much for cooperation, and let's continue. Well, and we have here our default streams, and it's quite related to the exercise that we have. Yeah, therefore, well, if you start thinking about default stream, why I need that? I have one parallel. Everything works fine. Yeah, but well, in future, you can get a problem because your infrastructure, your customers start to pick alternatives because they have a better version, for example. They are the better place in the repository. They have other advantages. They have a small, let's say, install size and so on. Therefore, there are reasons why you can get in problem. How defaults were mentioned or handled in modules. You have a special document in the module YAML that defines, okay, this stream is a default, and if a user doesn't specify by another way, it is the only visible content. Well, if we use our RPMs with the alternatives, I set up 3 examples what people might or wants to have. Yeah, therefore, if I run, DNF install parallel, I expect that I will get a parallel package, default package, because I would like to use the default. Why default? Because default is the most supported. The length of the lifetime is usually longer. Most of the software, or maybe the best, all of the software use that stream. Therefore, I will not get a trouble with imports or with additional feature and so on. Therefore, if I want to install a parallel and I use the compat packages, then any of these providers of the parallel can be installed. Therefore, let's think what we can do. Well, if one of the stream is built without a suffix or without original name, then DNF will pick a parallel because first it starts to search for the names. Therefore, if something is named parallel, then you will get the install parallel and nothing else. Well, what happens if you have a package that require parallel, yeah? Or you want to install alternative version of the parallel with your package, then you can specify in the requires. It requires or it requires the alternative parallel, or it requires original parallel. The last thing that if I have a package that requires any parallel, you know, my package does the most important part around the world. It asks for the version for the install parallel, yeah? And then you want to get any one. Then it's a problem because your package requires only parallel, and all of these alternatives provide the parallel. And for the solver, I can pick any of these. Therefore, I can use the parallel that provides the highest number, but it's usually not the default, or it is default at the beginning, but not later. Or, well, there is no restriction for the solver. Any solution is valid. And it's, of course, it's difficult. You can use a hint. That you can hint that, okay, well, I suggest that you will install default version of the parallel. Therefore, I will set something. It's a weak rule. It's a hint. Therefore, it only helps the solver. But it's a weak rule. What about weak rules? You can break them. Or if multiple weak rules appears, it happens, you know. No one is restricted to not use suggest parallel for not default, yeah. Anyone can do that. Therefore, it's weak in comparison to the modular system where rules are much more stronger. Well, another topic. I'm a user. I'm developer. Yeah. I would like to see how many alternatives I have for the parallel. Okay, with the modules, it was quite easy. Just write DNF module list a parallel, or I would like to list all of the alternatives. That's even more easy. No needs any argument, and I will find what I have interest. It's easy. Well, if my rules are strictly written only in RPMs, then, well, I have to play with the DNF repo query, for example, and I have to try a few commands. First, okay, the logical way, if I know how it is constructed, there is a parallel with the suffix. Then I say, okay, parallel and wildcard. Well, you will see thousands of packages. It doesn't work. Too many packages. Well, then more clever way, if I know that all of alternatives provide a parallel, then I can use what provides, but it will give you all of the versions. With the rel, it will be quite painful because, you know, each of the version of the parallel has a tons of the versions. Therefore, well, if I will also use a query format and I will ask for the name, then it will help because I will only get the unique names for the unique providers of the package, of packages that provides a parallel. Well, with the Python, that's even more funny part. Yeah, again, well, if I run repo query with the Python 3 wildcard, well, you will get a 5,000 packages plus, yeah, or yeah, even more. Then again, well, let's think about what it provides. Yeah, only one package provides Python 3, therefore it's not exactly. Therefore, you can use what provides, and then you can write dot, and then you specify a version. If you will not specify the alternative provides, you will again get quite a lot of mess. And or you can use you can start to think about using just searching for the names, and again, you have to use a specific pattern. Well, what is output? Or what do you think there is outcome from these two examples. Any idea? I need to use reverse engineering skills. First of all, I have to look inside for the packages. I have to find what it provides. And each of these needs another approach, how to get a list of the alternatives. And that's the problem. Yeah? You cannot use a unique approach. You cannot use, anyway, this is quite expensive anyway, these searches. You have to find what you have. Thank you. You have to find what you have. You have to look what it provides, and then, according to your finding, set some rules. It means this is not what you want to expect at this time when users wants to get user experience. Yeah, you don't want to do such a searching and your research just to know how many versions of that software or how many major streams I have in my distribution. Yeah, that's something that is, it's from the last century. Well, I also mentioned that we can use comms group to deliver a definition of the alternative content. It's quite similar to the module YAML. It's, there are some not nice features of the groups, like updating of the definition, and it doesn't support default. Therefore, if you want to use, for example, a mark default, then you have to name it. And if you compare how it can look like for the Perl and Perl DBI combination in comparison to the modules, you can get such a combinations. It will help you to pick the right packages. You don't need to care about the suffix or the renaming because you can use any pattern, and it's somehow human readable. But anyway, you have to read it and pick the right content. You see more alternatives for the groups because there is no logic that will pick the right content for you, like with the modules. And again, the combination with the defaults, it's getting more and more ugly, more for the depend stream than for the original providers. Okay, let's just look for the testing. Well, if I have one application and it requires 2 different packages, well, the testing is quite clear. It's one setup, I run all of the tests, and I have a result, it works, or it doesn't. Who knows? If I will provide alternative provider, even if it's not default, what is expectation from our users? That it will work. You provide that, you can install that together, and so on. Therefore, if you want to test it correctly, then you need to do it double tests. Therefore, with one alternative and the second alternative. Well, that's not the end. You can have also alternative for the provider B. Well, there are already 4 combinations, and we are just starting, That's the problem of alternatives. Therefore, there are so many combinations. If you provide any alternative software, our users expect that it works, and it's tested, and we've marked it, our distribution is tested. But, not this combination. Or this one, but you don't know. Yeah? Therefore, this is expected. You already have 4 combinations. You have only 2 streams from the 2 providers. And, you can look how many alternatives you can have in RHEL or in Fedora, or look to the past, where you have multiple alternatives. You have to also things that people built on top of that. And they can use, they can pre-select certain set of the combination, or they can have, they allow all of the combinations. Therefore, the matrix for the testing is increasing dramatically each time when you increase the when you arise when you provide new alternative. And as I said, well, right now, there are completely different expectations from our users. Our users expect that everything will work. They expect that it is tested, it's easy to use, and that our distribution is not the set of the packages, but it makes together sense. Therefore, there are different expectations than in past, and we have to count. We don't have to count on that that they will be tolerant. And you cannot tell them, you install alternative. That's your fault. Yeah. Use a default. What's the default? Yeah. Difficult to say. Well, and let's come to the end. Let's talk about the summary of this. Therefore, the first part of the summary is just focus on you as a developers who wants to provide alternative features, alternative content. The short summary would be, don't do that. No, but you usually need or you want. That's the small difference. If you need, that's fine, but you have to calculate the price. Doesn't matter whether you will use modules, whether you will use compat packages, whether you will use a vendor label like in SUSE. Everything has its own price. Yeah, you will receive new problems, new combinations, unexpected combinations, because users are pretty productive in using your products in the way that no one expects that they will be used, but it's valid. We provide tooling, therefore, and they use it as a tool. Well, therefore, not only think about maintenance costs, testing. Please test all your combinations. I know it's impossible, but think about that. It is expected from our users that we provide tested solutions, not a random one. Yeah. Think about that all alternatives we provide the problems with the package builds. As I said, important are defaults. If you pick the wrong default, then your user experience with your packages will conflict with the rest of the distribution. And think about user experience. Therefore, if you would want to use modules, please try to somehow make it easy your users to find your alternatives, to find the documentation, and the best way, think how to do it on the distribution level. There are right now, I don't know, 30, 40 groups that might want to provide alternative software. If each of them will invade the solution, how to list all of the alternatives, then each user needs to know all of these 30 combinations, how to get the list. You can even create your own app and say, okay, list all of my alternatives. It works, yeah, and everyone says it works. And users will say, you are crazy, yeah, because I have to, how I found your solution to listing all alternatives. The problem is there are tons of ways how you can deploy alternatives. Therefore, you cannot find similar patterns between each teams. Therefore, please open the discussion on the distribution level, how to make life of our users much easier. Well, if you have modules without modules, doesn't mean that you cannot sell them as a module. You can still ship non-modular packages with a modular YAML. Therefore, and you can disable, as I already mentioned, features. Therefore, modularity is not only about the build system, it's a complex stuff that can be interfere with the multiple things, with multiple sides. And additional things, if you think that the best way is to introduce a new type of the metadata, please careful, because any new metadata causes a lot of problems in infrastructure, in satellite, and many distributions will drop them because they don't know that, and they will not sync your content. And if you will decide to go this way, or your distribution, then please unify it and don't expect that in 5 years you will again want to introduce another way how to list your alternatives. Well, thank you very much for the listening, and let's open a discussion. Do you have any questions? Go on.
Can we just kill it?
Me? No. Okay, the question is, can we just kill it? And well, and then additional note modules. Maybe let's not answer this question. Let's ask another one. Doesn't matter. It can sleep. Well, don't ask that question. Ask, do we need alternatives? That's the question number one. Do we need alternatives?
Well, let me turn the question around again. Do we need it in form of modules instead of, let's say, containers or anything else?
Well,
Containers are one of the consumers of modularity.
Well, can we do it different way, which doesn't drive everyone insane?
No. Any way you're going to do alternative software is going to drive you crazy.
okay, the answer from Neil is that, well, no, because any way how you will do alternatives, it will make you crazy. And that's maybe what even I said, yeah? Therefore, in definition, alternatives make problems. Doesn't matter how you will land them, you will only experience different types of the problems. Therefore, it's a trait. I don't want this problem. No problem, you will have this one. Is this what you want to? And okay, well?
Or you can have both problems.
Yes! But yeah, and mostly you don't see them both at the one time. You experience one by another one, especially during the life cycle and so on, therefore, yeah. Okay, another question. Go on. What's the current state of the application? Deprecation of modules? You want to see them in the RHEL?
Because in RHEL it's right now a list on a page, and if it would be metadata, the system could tell me that this is the module is there.
That was always there. Nobody ever wanted to use it.
Okay. With that answer is that, there are some attempts how to get rid of the modules, and we have to talk about whether we want alternatives. This is for my side, the most important questions. Well, you can ask what is worse, yeah, to have a modules, or you have alternatives without the definition. Therefore, you will not see any list of the alternatives. You will be maybe, you will sleep calm and so on, but sooner or later you will get all of the problems. Or, you will get different set of the problems. That's the funny part.
But they won't get rid from RHEL 8 and 9.
You can't.
Yes, but if there would be the deprecation metadata in 8 and 9, that would help because the modules get deprecated.
Okay, the question is whether we can get rid of modules from RHEL 8 and 9. The answer is no, you can't, because for one good reason. What is expected from our users of the RHEL? That will not change. Yeah. Okay, I am out of the time, but please don't hesitate to ask me any questions or open any discussion after the talk. Thank you very much for listening, and thank you for the questions.
Okay, so let's go. So this talk is about MKSI initrd, which is an alternative way to build initrds. And the official title had in Fedora, but the Fedora part kind of shrunk over time. So now it's like MKSI initrd and a bit of mention of Fedora at the end. And so let me start with a justification. And this justification will just refer to the talks on Friday. So there we had some excellent talks about confidential VMs. And confidential VMs can be summarized as you are not allowed to run any code which has not been signed and verified to be the right thing delivered by the vendor or the owner of the machine, whatever. So we need to have everything immutable and signed and checked. So if we, and this is certainly the case for confidential VMs, but it's also the case for other things. Like, for example, you have a device somewhere on the edge, and you just want it to do the thing that it's supposed to do. And if somebody comes in and swaps the disk, this shouldn't allow them to do anything with the device. So if we start at this point and say that we have to run signcon only and go back from there, well, this currently we have only one way to deliver kernels that are checked, right? It's to create a unified kernel image which combines the kernel and the initrd, and the whole thing is signed together. Well, okay, it's not the only way. That's not true, but it's, I would say, the best way. And so if we are supposed to sign the initrd, it must be built by the distro, because we need to build it first before we can sign it, and the keys are somewhere in a vault somewhere. So local modifications are not possible. They are not useful in this model. So the current system that we have that has been built around local modifications and doing things at the end machine, it cannot be used anymore. So let's say that we design a system from scratch. What we would do, instead of this fairly complicated thing that we have right now, is well, do things in the simplest way possible. And this means that we take upstream packages, distro packages, which already have our software in a form that is ready to be deployed anywhere, and just build an initrd out of this. And this is what MKSI initrd is. So, Martin, you have questions? Because if anyone has questions, then please raise a hand. I think if I'm talking nonsense, then it's better to clear it up during the presentation. Right, we have, in Fedora and RHEL, we have Dracut, but other distros have similar systems that take files from the hostfs, do some magic to resolve what dependencies should be installed, so LDD on binaries and maybe some special hacks to figure out things. So essentially, when you are building an initrd, you are redoing the work that was done by packagers previously, just in a more hacky way. So it's like, essentially duplication of the packaging layer. You have a dependency mechanism and conditionals and a lot of that stuff. And of course, this takes time on each end machine. So this is what happens before, while we are building the initrd and before we install it. And after we have installed it, the initrd is very special. It has, so with Dracut, we have an init queue, and we have special code. So for example, in Dracut, we have bash code that generates bash code that generates bash code. And so now things are complicated, different than in the host system, and it's, if you want to debug things, you need to know both the thing you're debugging and the initrd, and it's just complexity. the environment is set up in a slightly different way. And what I want to underline is that not everybody is aware that our initrds use systemd in the initrd. So we start systemd in the initrd. It sets up the whole system in the way that it likes it to be set up. So all the /proc, /sys, /dev is mounted in exactly the same way as on a real system. And it starts services in the same way and so on. The difference is that the root of the file system is a temporary file system instead of a real file system. But the logic and the API is the same. But we add to this, and we have the systemd queue for jobs, and we also have the Dracut queue for jobs, and they kind of interact and play with one another in some semi-defined way. And another issue that I find with this system is that every distro does a different thing. So the alternative approach is to say, well, let's do less. Let's build images from distro packages, and MKSI was a kind of a script, a wrapper around package managers that was initially written to test systemd, and it builds images, but it's actually fairly convenient to build initrd archives with it, because it has like support for different package managers and conditionalization and stuff like that. But MKSI is not the important part. I mean, we could replace it with a different system, and it would probably work quite as well. But anyway, so MKSI builds images from distro packages, so it's kind of like a fancy wrapper around change root and DNF. And for the last upcoming, well, for the upcoming MKSI release, we have done a lot of work. So repart has been rewritten to write stuff directly to a file without using a loopback device, which allows for unprivileged operation, which is very nice if you are building images as a normal user, or you're building images in a container because you don't need root privileges. It has been converted to use DNF5. A lot of work has been done like on the way that the configuration files work. Now you can do profiles and conditional logic based on matching. So for example, you can have a shared config as one file and a subset that is specific to each distro as a separate file with a match section, and then you end up like with a limited amount of duplication. So all those things, they are part of MKSI 15, which will be released as soon as Dan says it should be released. So maybe next week. And so we have MKSI, and now I can say what MKSI initrd is, right? It's just a few config files. So the main thing is a 20-line file that lists packages that should be installed in initrd. And this is, well, okay, so what are the benefits? So this is a really, really minimal system, right? MKSI itself is not, well, it's kind of complicated, but it's essentially a wrapper around DNF. So the heavy work is done by packages, and we use the package dependency resolution mechanism to figure out everything that should be installed. This means that our packages have to be packaged well, but we do that work anyway, so that's okay. Right, and we let the existing tools handle 98% of the work. We are independent of the host. So I want to build an MKSI image for Debian or for Gentoo or Arch on my Fedora system. This works without any problem, and the other way. So I mean, this is this is not just a question of not being, I mean, it's kind of ugly to pull files from the file system because they might have been modified locally or something might be off. But it's also important for stuff like build reproducibility, right? If you are supposed to sign something, if you take it from packages, you know that the package manager will verify the hash of each file as it is installed. And if you repeat the installation, you expect bit for bit identical result. So there's much less variation. Yeah, the images can be reproducible, and well, fortunately or unfortunately, everyone gets the same image, which is a problem I will talk about later. And it makes sense to sign them. And we reuse systemd, right? We get rid of those additional helpers, bash stuff in the interd. Systemd does the setup. And the execution environment in the interd is exactly the same, well, not exactly, but it's very similar to the host environment, right? You open a shell into the interd, and it's like debugging a normal system. The root file system is different. And also, I don't know, like you want to install SSHD into the interd, you specify an additional package on the list of packages to install, and SSHD pulls in the dependencies, and you don't really need to do anything else because the packaging has already been done in this way that you can pull SSHD into any system and it gets started as part of the normal systemd transaction. Yes?
So I guess MKOSI has to pull some extra tricks to make sure that the image is reproducible, because reproducible RPMs doesn't mean that the resulting image is the same vibration.
So, I mean, reproducible in the sense that if we take the exact same of RPMs and install it, we expect the same result because we install them in a fixed order, and it's a bit hand-wavy because it's possible that it doesn't actually work. We haven't really tested this properly because, I mean, there are other problems, but in principle, there's really no reason, right? I mean, the set of RPMs is fixed and the installation order is fixed, so we expect predictable results.
I think about it like post-installation scripts which create files possibly with different timestamps and possibly even contents.
Yes, we have to, yeah, so it's like it gets into the same problems as building of RPMs reproducibly. You have to do some adjustments to fix timestamps and so on.
The last thing is the relation to the tool is doing less, because otherwise if you want to put in all the kernel modules from the kernel packages to be the part of the image, because you have to take basically whole RPM for that.
Yes.
Where is the point? Because you will quadruple or many times increase the size.
Well, maybe twice, and so I'll get to this. This is a valid problem, right? So what the linear is bigger, but it's not terrible. So first of all, I don't have like I don't want to talk about specific numbers, but generally it turns out that you would expect that the interd built with Dracut is so much smaller because it has a smaller set of files, but actually that's not true. Like, because almost everything now is delivered as a binary and some libraries. If you follow the package dependencies, you get almost the exact same set of files because just you need the same libraries, and most of the space is used by the libraries for code. So there is very little difference in this regard. Then we have some stuff like the hardware database, and I'm installing that because that's part of the RPM. Dracut is not installing that, but I think it's a bug in Dracut, so there was like little differences. And then the big difference is the stuff that you said, that, well, what to do about kernel modules. And what I'm doing right now is I'm just installing the kernel modules core RPM that has all the modules. So that's 30 megabytes or something like that. it will be possible to modify this, right? I mean, I'm saying that we want to install everything from packages, but it's not like we cannot. I mean, we already remove some files that we don't want, and we can also remove maybe, I mean, if there's no other choice, we can figure out a mechanism to select a subset of modules. This is doable. Hmm? Okay. And another way to answer this is that, okay, so the initrd is, let's say, less than 100 megabytes. For current machines, this is actually tiny, right? I mean, you can have Go binaries that are multiple size of that. And why is that such a problem to have an initrd of this size? It's a problem because we load it at boot and decompress it and put it in memory. And there's an idea to use initRDs that are not CPI or archives compressed, but they are, for example, ERO-FS with internal compression. So you get like a block device and only uncompress the stuff that you use. And then, so this needs some small kernel work. And then you sidestep the problem because you have an initrd that is a gigabyte and you wouldn't really care. I mean, depending on how much memory you have. So, I mean, right, because copying of 100 megabytes in memory, it's a fraction of a second, right? It's the uncompression that is the problem. Yes, the kernel modules. And also, what works in initRDs that are built this way is the stuff that is directly supported by packages, right? So for example, LVM is not a problem, and normal installations with Btrfs are not a problem, and encrypted disks are not a problem. But iSCSI is currently implemented in this way that there is some very complicated logic in Dracut that does string matching and builds the configuration on the fly from some other stuff. And I don't want to repeat that. I want to change the package so that it supports running in the initrd natively and let the package managers or package authors deal with that and not to have special logic. Okay, so let's say that we build the image in distro infrastructure, and everybody gets the same image. This is nice if it works, but it will not work for everybody because people need to do some local modifications. So, like the side step answer is to just build multiple initrd, and we will certainly do that. So currently in Fedora, we build a unified kernel image for virtual machines, not with MKS initrd, but with Dracut. But it's it has an initrd that only supports booting in all types of cloud VMs. So it has enough kernel drivers and enough software to work on virtualized hardware and not on other things. We could and probably would do a bunch of variants, but we also need other ways to extend to provide local modifications, and there's a bunch of answers. And over the last, well, year at least, in the systemd project, a lot of work has been going into this functionality. So it is needed if you want to have read-only signed images that you run, for example, in the cloud, but it also is the same problem for the initrd, because you want to have an initrd that is signed and is read-only, and then you need to extend it. So I want to talk about those approaches. Credentials, right? We have a blob of data. We store it somewhere. We have multiple ways to store the credential, and I talked about this during my talk in the morning, so I'm skipping over this. But the important part for confidentiality is that we can encrypt this. So we encrypt the credential with, they have this here. We encrypt it with a file that is stored on local disk that is protected with LUKS, so it's a secret. We also encrypt it using the TPM. I mean, either this, either that, or both, and both is the best answer. And then we have a credential, which we can actually place in the ESP, where it's public, so to speak, but it is secret because you cannot decrypt it, and also the encryption works as a authentication layer, but because if we decrypt something that was encrypted in the wrong way, I mean with the wrong keys, then it doesn't, the file will not be accepted. So this is one way that we can have stuff, the local modifications. They're created on the running machine and then they're placed in the ESP. Second mechanism is configuration extensions, and this is kind of a new concept, but it's a variant of something that was there already before. So we have system extensions and configuration extensions, and they're kind of the same. So it's a discoverable disk image that has a partial contents of the file system that systemd will load at runtime, use overlay.fs to make it visible in the file system, and system extensions are for code that is in /user and /opt, and configuration extensions are for /etc. So you can drop those images, those extensions into the right places, for example, in the ESP, and they will appear in the initRD once systemd is up. The discoverable disk images can contain DM-Verity data, and the DM-Verity data is protected by a root hash, and this root hash can be signed and also embedded in the DDI. So systemd will tell the kernel to use the kernel keyring to authenticate the contents of the extensions before they're being used. Yes, discoverable disk images. This is right. So systemd dissect will tell us that okay, the thing is an extension for system images, for initRDs, for portable services, depending on the metadata in the image. And so here is an example. We have so this is a disk image, and it has a user partition, /user partition, and an ESP partition, and Verity data as a separate partition, and a signature for the Verity data. This is all separate partitions in the discoverable disk image. So GPT as a file system table. And we have yet another mechanism, which is add-ons. So an add-on is a Yuki-like binary that has a section, and the section has kernel parameters. So, I mean, this might sound crazy, and I think it's a bit crazy, but the reason is that because it's a UKI, it means that it's a Microsoft PE binary, and this means that we can feed it to shim, and shim will tell us using the secure boot infrastructure whether it has a valid signature. So we are putting a text file inside of a binary that is signed by some key, and this way we can verify the whole thing. So returning to this list from before, we have the variants, we have credentials, we have extensions that are checked by the kernel keyring. So this ultimately also means the secure boot infrastructure, and we have the add-ons. So it's, I mean, different options, and the addition of those options is what I think makes the whole project viable, because we will have ways to deal with the with just not having flexibility in the initRD itself. Yes, so I mean, the stuff that I talked before was kind of like on the more on the systemd side, and on the MKSI initRD side, there has been work done to integrate with kernel install. So kernel install gained a few plugins for different things related to UKIs and MKSI initrd. So we have a kernel plugin to invoke MKSI initrd to build an initrd. When you call kernel install, we have a plugin to, and for some reason I forgot to list it here. We have a kernel plugin to call UKIFI to generate an image, and UKIFI gains support for config files. So if you put the right config file in the right place, this operation will create a signed image. And then we have a plugin to copy the unified kernel image into the right place on the boot partition after everything has been ready. And this stuff is opt-in, so you need to specify some config, very simple config in various places. Well, because it's kind of experimental and we don't want to break systems yet. And also bootctl kernel identify is a helper that will tell you what the kernel, what the type of the kernel is, and kernel inspect will print details about unified kernel images and so on. So I'm to wrap this up. I mean, in some ways, not much has happened in the MKSI RD project over the last few months because there isn't really that much to do from the MKSI RD side. The work has been happening in other places. And I think we're kind of getting closer to the point where it becomes useful for real users. In principle, we have a change for Fedora 39 to make MKSI initrds available. I'm pretty sure that this will not happen, but maybe for Fedora 40, there's some outlook how to build such images in Koji. Grub2 might get support for unified kernel images. I mean, patches are out there, they are being reviewed. There has been progress on making kernel modules easier to install. We don't need the whole, I mean, it's still a single package with a big set of modules, but at least it doesn't contain the kernel anymore. And this was done because of the change of introduction of unified kernel images for cloud VMs. And I mentioned that MKSI works unprivileged, and there has been some work on integration. And links and well, questions, comments.
I'm kind of curious about, like, I think I saw some you were using loop back device and stuff, but you say that you're doing the builds unprivileged. How do you like create the partition and populate the stuff?
So I guess this is so. If we, so the initrd is a CPIO archive, and actually we can build it without any privileges. So the stuff that I mentioned about running without privileges is when we build a DDI. So like, for example, a system extension would be a DDI, and then we need a file system. The initrds actually don't have a file system, and they are built unprivileged without any issue. So the building of initrds locally using this mechanism, it's like it's supposed to be a temporary step, right? In the sense that, yes, we do it and we also need it for development, and we also always need to do it for development, but for end users, we want to build the initrds once and deliver them as a package content. So basically you have a, like with the kernel package, you have an initRD package and you get the initRD there. Or even better, you have a kernel package that has a unified kernel image with the initRD already embedded.
And do you work with this in the area that you will initiate split of kernel module package to much finer set of modules? So for your virtual machines, you literally need only a couple of modules. So there should be a split of RPMs for support of this.
So I have to admit that that was my idea in the beginning, but maybe it's actually not that useful. Maybe we want to do, I mean, the fact that the modules have been split out from the Linux binary, this is nice because they are both big and we don't want the Linux binary at all. But the selection of specific modules, it could be done this way or it could be done using some filtering mechanism. I'm leaning towards the second option now, but either way. Yes?
Let's say you have to increase support for weird disk format or something in Ionic. We build a system extension, right? With the files and the heap.
That would be one option, yes.
Then we sign it, and then we put it alongside the UPI, for example, in the ESP. And then how would we tell the bootloader to use that? Do we just concatenate the files, or do we have to write davis config?
So, okay, I forgot to repeat the question. So the question was, if we have some special hardware or file system, and we want to deliver the code to open up the file system in the initRD as a system extension, how does it work? So the way that extensions work is that very early, when systemd is booting, it starts a service. The service locates any extensions that are present and signed properly, and they at some point just appear in the file system. So this happens in early boot. So if you have this extension would essentially be overlaid, and then the code inside of it could be used at a later point during the boot to mount the root file system or the whatever storage.
How do you differentiate between versions? Do you need to have one extension version for each API from your system, or how do you do versioning there?
So there is a mechanism to match extensions to the running system or the image.
For example, still in the classic system for RBM2 systems, we have several versions installed at the same time. So you have two kernels, for example, in the ESP, and two initRDs. And so eventually we would need one extension version for each UPI and initRD curve. So how does you know from the initRD that you should take this version or this version of the extension?
Okay, so the question was, if we have multiple kernel versions, and how do we match extensions to the right kernel version? And the answer is that for each kernel, we have a specific place for extensions for this kernel, and we also have other places for extensions for all kernels. So there is a mechanism to do the matching. So the question was whether the installer has to care about the installation of the kernel and whether it will be installed by the RPM packages. Yes?
Yes. Basically, right now, I recognize doing the build of the initRD twice, because one is because of the package, and second time it's after it's fixed and everything is set up. So the question
I'm not sure. I mean, essentially, it would be maybe copying a file a second time, so not a big issue. But so I'm out of time, so let me do a demo. So let me show the config for MKSI initrd. Sorry, MKSI conf. So this is my config file, and it lists packages, and it says that the output is CPIO. And now we call MKSI, and since this is without, I mean, a demo, I'm doing it without network. Oh, it failed because it exists already, so let me do it with -f now. And we do the package installation, and we do a setup, and then we remove some files so that the initrd is smaller. Here, those packages are only needed for installation, and then they get dropped. And we have an initrd somewhere here. It also comes with a manifest and a changelog so that we know what is inside. So like hashes of stuff. Okay, thank you.
Okay. Everything fine? So, good afternoon. I am Andrzej, and I am working as a software engineer at Red Hat, and I am working on a project called Image Builder. And today I would like to show you what's new and how you can use Image Builder to build some nice, up-to-date, customized, and shiny images. And yeah, by the way, I am going to skip over some of the details, so feel free to ask if something is unclear. And also, we have a website, so if you want to know more details, go there. There are some guides, and you can follow them basically to do exactly what I am going to show you here. So let's not waste any more time, and go directly to the important bits. So, what's Image Builder? Image Builder is a modern tool for building operating system images. We will go into the more depth which exact images we can build, because images, it's kind of a generic term. So we will explore this more later. But the basic facts are that we are building them from scratch. So basically, we will download all the repositories, RPMs from the repositories, and then somehow combine them in order to create an image of an operating system. And it's important to know that there are no VMs involved, which is quite nice because a lot of modern cloud environments don't have support for running nested virtualization. So it's kind of nice that you don't need to spawn a VM. But of course, then the other method that you can use is to use containers, and like namespacing. So it needs root. So no VMs, but root required. The important fact is that Image Builder never boots the image, so it makes really sure that it's pristine. And we will get to this later, why this is interesting that the image is never booted. And yeah, this talk will focus on Image Builder that you can install on your machine. We have also some other options where we will host Image Builder for you. But yeah, I will mention them at the end of the first part of my talk. And yeah, so that's Image Builder, modern tool for building operating system images. Now, what images can it build? And I will start with distributions because that's the first thing I want to mention. So we can build Fedora and its children, which means CentOS Stream and RHEL. And for Fedora, we of course support all the supported versions. For CentOS Stream and RHEL, that's 8+. So yeah, but the more interesting part is for which environments Image Builder can build images. And there's plenty of them. So I actually put them on 2 slides. The first slide is about all the cloud images that we can build. The first bullet point is called KVM, and that's what I like to use for these environments where it's pretty much just KVM without any specialties, which means libvirt, so you can just virt install the images, OpenStack, or KubeVirt, OpenShift virtualization. There was a very nice talk earlier today, so if you are eager to try KubeVirt after this conference, you can also use Image Builder to use a custom image there. And yeah, then we support also all the major cloud players, for example, AWS, Azure, Google Cloud, Oracle Cloud, and VMware vSphere. And from my experience, the KVM image, if the cloud provider uses KVM underneath, the image usually works. So I, for example, use the images from Image Builder at Hetzner because you can just upload it there and it works because they use KVM. So it's pretty cool. So these are the cloud environments. But we can even build more, and these ones are, yeah, more interesting, I would say. We can build installer ISOs. So basically, that's Fedora has the installer, and Image Builder can build a customizable. We will get to there later, but it can build a customizable installer that you can then use to install as many bare metal machines as you want, or even virtual machines, but please use images for virtual machines. It can build containers like the OCI one, so Podman. Just a word of caution, we don't support custom container files or Docker files. We are really meant as a tool for building the base. So, if you want to build something on top of Fedora, you specify from Fedora 37, and Image Builder can build this base. And the last thing that we can build are OS3 artifacts. Currently, that means Fedora IoT or RHEL for Edge in the RHEL world. And we can build all of the artifacts, so comments, installers, raw disks, simplify this, containers, that's pretty much it. And that's pretty cool. But I won't dig into this deeper because I think that during this conference there were like 3 talks about Fedora IoT and RHEL for Edge, and each of them mentioned Image Builder. So if you are interested, just watch the recordings. All of the talks, I was there, they were really amazing. And just the last word of warning, some combinations are not supported yet. So for example, you cannot build a container of RHEL currently, I think. It's not implemented, just because no one had the time to do it. But if you are interested, please contact us, and usually it's pretty fine to fill, it's pretty easy to fill the matrix. But yeah, there might be some gaps in the support. So that's what images can it build. But of course, there is one more thing, because base images are nice. But base images are also boring, right? You can also very easily build customized images. And that's where Image Builder really shines, I think. We can do plenty of customizations on the image. And let's go over them. I picked the most interesting ones. And then at the end, I have the new ones, which are pretty important and interesting. First thing first, we can do custom partitioning. Custom partitioning, that's where Image Builder really shines, I think, because, for example, Packer is an alternative, but Packer boots the image and then does something to configure the image, then it takes a snapshot. But when you want a custom partitioning, for example, when you want to separate /user or /var, on a booted image, it's kind of, well, it's possible, but it's really hacky, and just don't do this in production, please. But Image Builder doesn't do it. Like everything happens on, not booted systems, so it can do whatever partitioning you want, which is pretty nice, and you can even use it. Yeah, we will even use it later on this slide. It can, of course, install extra packages because we believe that the base operating system should just carry enough stuff so it boots in the target environment and nothing much more. But that's pretty useless. You want something like HTTP server or I don't know what. Fedora has 50K packages or even more, so there's plenty of stuff to install them there, and Image Builder can install extra packages. Also, it can add users, which also, you can do it, for example, in cloud. You can do it via Cloud Init, which is a good tool, but maybe in certain cases you want predefined users, so all of your deployments are the same, and you have, for example, one admin user with the same SSH key everywhere. Maybe it's good to put it into the image itself. Why not? It can simplify your deployments if you need this. It can configure a firewall, of course. Once again, that's pretty nice because the firewall is configured immediately after you firstly boot the instance, which feels kind of secure. It can manage systemd units, which is, it ties nicely to the extra packages because web server is cool, but if you cannot enable it, then it's kind of doing anything. It doesn't do anything. So that's thing. And yeah, now let's go to the new stuff that we introduced in past few quarters. One of it is hardening, which is based on OpenSCAP. Basically, how this works. So OpenSCAP is a tool. You give it a profile, and it scans your whole system and applies some remediations. And these profiles are basically based on certifications. So if you need certification ABC, you apply a profile ABC, and OpenSCAP will try to do as much as possible so your system is certifiable by the ABC certification. And Image Builder can apply such such remediations on the build time. So once again, the system is hardened from the very beginning, from the very first boot, which helps to establish a secure pipeline. Also, a lot of the certifications require a specific partitioning, and it kind of ties together, right? You can use Image Builder to do the custom partitioning and also immediately harden the file system, like the system. So these two features are very often used together. We can inject extra files into the image, and that's also very useful because you install a web server, you can enable it, and you can also configure it. So you can have an image that immediately starts to behave as a reverse proxy, for example. And the feature that I like maybe most from this list is embed containers. What this means, when you tell Image Builder to embed a container, during build time, it will download the container from the container registry and put it into the right directories. So when you run podman or microshift, it doesn't need to pull that container, but it immediately has it on the system. And this is great if you have a disconnected environment, because then of course you don't have any container registries, or for the IoT/edge use case, because your device might be on top of a hill and there is no good internet connection and you don't want to wait 10 minutes for a container to download for a registry. So that's quite useful for these kinds of scenarios. And yeah, I just wanted to mention that, yeah, OpenScape, by the way, so you can, so you know what it does. So for example, it can do some small changes to the configuration, like changing configuration auditing, SSH configs, OpenSSL configs. I mean, base distributions are nowadays pretty secure, but these certifications require more, and we don't want to put this config in the base system because sometimes the system might behave weird because users want to use kinda, older hashes and things like this. So it's always about trade-offs. Anyway, there is one more thing that Image Builder can do, and it can immediately take care of your uploads to the cloud, which is pretty cool because because if you've ever tried to do multi-cloud image uploads, it's a pain. Like, I uploaded an image to all of these, and IBM Cloud actually also, and OpenStack. And all of these CLIs are different. The process is different. You need different compartments. That's my favorite word from Oracle Cloud. You need different storage groups, storage accounts, storage containers, whatever. It's crazy. And of course, you need to have all of these CLIs installed on your machine, and it's annoying. But Image Builder abstracts this away. You just give it a config, and it will build an image and immediately uploads it to a cloud. Which is very cool, because to be honest, we believe that this should be more, more tools should do this, because building an Azure image locally is fine, but what are you going to do with it? Yeah, you can boot it with QEMU, but it's an image meant for Azure, so it really should end up in Azure. So we are trying to tie this, these two processes together, because it really makes sense. Anyway, yeah, so the image builder that you can install locally, it uses both GUI and the CLI, and at least my understanding or my vision is that you can play with the GUI and see what Image Builder can do, and kind of click around and add customizations, define everything nice and visually, and then when you are done, you can just export the blueprint, and then you can just use the CLI and set up an automated CI pipeline. Yeah, I consider this as a two-step process every time. Yeah, and if you want to build an image or start building images, it's very simple to install. Just DNF install two packages. One is the CLI, one is the GUI, and then enable the service that runs on the background and builds images, and you can start building. It's that easy. Yeah, good. Now, I promised that I will talk also about other options how to consume Image Builder. And it can be also run as a web service. And currently, the web service has 2 clients. One, well, 3, but yeah. One builds golden RHEL images, and one builds a golden, currently, Fedora IoT images. So that means that Image Builder can be integrated with Koji. And it builds images every day. The second client is our image building service in Red Hat Hybrid Cloud Console, where you can just grab the free RHEL subscription. It's fine, go to console, there is a link here, console.redhat.com/insight/image-builder, and Red Hat will build the image for you, and you don't need to maintain any infra. We will just send you a link or share the image into your account, and it will just work. So my message here is that Image Builder is run in a production environment and it's suitable for everyday use. So just use it. It's stable. It's fine. Good. Is that? Yeah. And I should also mention that that the service has also an API, so we can also automate your CI pipeline using the hosted service, which is pretty neat because you can just call it from a container in GitLab CI, and it will just, or GitHub Actions, and it will build you an image. There should have been an image of the service, but yeah. Anyway, and just 2 items for the future. We would like to collaborate more on using Image Builder to build more Fedora artifacts. Currently, the project is with the installer team. Hello. Because we are talking together to building Fedora installers because we would like to modernize the image building stack. And also, our big dream is to enable the community to easily build and share customized Fedora images because we think that the process currently, there's Koji, Bungie, Relang, and it's like it's pretty a big process. So we want to make something that would simplify this process by a lot. I also forgot to mention at this slide, the image building service, I just like how everything ties together in this conference, like with KubeVirt, I mentioned, what did I mention? RHEL for Edge and Fedora IoT. And the service, it's actually tied to the keynote because it's an open source service. And yeah, it's one of we try to follow as much open service principles as possible. And Simon here is going to have a talk right after this talk about open services. So you can go there. Anyway, that's a bit of promo. It's demo time. Good. So this will be the part which can go wrong at any time. So I have this small shell script. I will show you it. I will show you the script in a bit. But I will build a config called demo for this demo, and it will be a QCOW2. So we will boot it in a bit with KVM, with just QEMU. So I will start it. And now I have about 5 minutes to explain you what's going on because the image will be ready in 5 minutes. No uploads will be done because of the Wi-Fi here. I don't want to risk it, so it will be local, but whatever. So the image is building. By the way, I will quickly show you the script. It's pretty short. I have some debug stuff in there, but basically I'm just calling Composer CLI with a bunch of commands and then parsing it. It's pretty simple. I made this script so I don't need to go over all the steps because they can go wrong, so I automated it a bit. This script, by the way, will be available at the archive of my talk after the talk, probably. Anyway, let's go to the configuration. We call this the blueprint, and this is what Image Builder consumes. It's a TOML file, and you can put a lot of stuff in it. So let's go over it and see what our image, when it's done being built, what it will contain. So a nice feature that of Image Builder is that it can do cross-distro builds or cross-distributions builds kind of easily. So my system is actually running Fedora 38, but for some reason I want a different distribution. So the image will actually be Fedora 37. So it's completely possible to do that with Image Builder. You can also, for example, build CentOS Stream 8 or CentOS Stream 9, and yeah, that's it. The next thing that I want to have in my image is Podman, because I want to demo the embedded container thing, and I need, you know, a container, how do you call it, container engine. So I installed Podman, and some optional dependencies. I'm not really sure why they are actually needed, but that's a story for another day. Not sure if that's a Podman bug or I don't know. So yeah, this will install Podman inside of the image. Then I want to embed a container. So I can just tell Image Builder, hey, download me this container. And yeah, I give it, you know, the source, which is my repository at gitlab.com. It actually contains the slides of this talk in a web server. And yeah, it will just save it locally as a talk container, just talk. It will be named talk. And that's it. But you know, downloading a container, that's boring. So let's run it. And for this, I am using the new Podman Quadlet generator. So let's explain it a bit. It's very cool. It's cool, right? So basically, it's a system. It looks like a systemd unit, and systemd can consume it via its generator thingy thing that Podman implemented. And so it is a systemd unit, right? It has a unit thing, and it apparently runs after network target, so after the networking is up. And it can be even installed. So like when I install it, it will run, or it will be required by the multi-user or default target. So it's a systemd unit, but there is no service, but there is a weird container section, which basically the generator will translate it to a service, and it will translate this to a Podman running Podman container. So I can just tell it, hey, take this talk image, which you know I downloaded in the previous step, and you can do the usual stuff that Podman can do. So I can just tell it, hey, publish me these 3 ports because it's an HTTP server. So I want ATN 443. And of course, the container is embedded, so I can just tell Podman, hey, don't ever pull it. You already have it in the store. Yeah, so that will save me some bandwidth potentially. I also expect maybe with my image that that I will need to store more data. So I put there an extra var partition with 10 gigs of size, and yeah, it will be there. So this is the example of custom partitioning. Yeah, there is just a quick note. Btrfs support not yet in Image Builder, but we are getting there slowly. So this will be just X4, but I mean for the cloud I don't really care, so it's fine, I think. Then let's harden the image, which is this section. Basically this tells the OpenSCAP tool that's run during the build time to apply from this file. This is like a real file that you can install on your system, this profile, and then OpenSCAP will run anything what's defined in this file, and you know the scanning, as I told you previously, it can, I don't know, configure SSH to not allow password keys. Well, that's disabled by default in Fedora, but I don't know, some other stuff like enable USB guard and yeah, whatever is needed in terms of security. And there are different profiles, and on our website there are some examples of other profiles that you can use, and you can also see the OpenSCAP documentation for more details. Anyway, let's go to the next customization. We can add firewall. So just install firewall D and immediately configure it. So we want to allow HTTP and SSH, and that means that all the other ports should be closed. And the last thing is adding a user. As I promised you before, Image Builder can add users. And yeah, I can just create an admin user. I can add my key. This is my public SSH key, and I can add it to the wheel group. But the issue is that so the wheel group is, you know, for accessing sudo, and the issue is that Fedora by default doesn't allow passwordless sudo. But that's fixable by the files customizations, because I can just add a drop-in and wheel will be passwordless. So that's possible. Good. Let me just quickly open the front end. This is actually the front end. So you can see that the demo blueprint that I put into Image Builder via the script, it's there. So it's the same thing as I did on the CLI, just visualized here. And you can see that everything that we talked about is here. So there is the OpenSCAP thing, OpenSCAP remediation, there are the file system options, firewall, users. If I go to packages, there are some extra packages. You know, there are also with versions, which is pretty nice. Custom files are currently not there. We still need to add them, but otherwise everything is there. And you can just click Create Image here. You know, select that you want QCOW2, and it will build an image for you. And you didn't need to touch the CLI, but we like CLI, right? Anyway, so yeah, while I was talking, it took about 5 minutes to build the image, and I downloaded it as an image, as a file, and I will just use a simple script that I have to deploy it. This just calls QEMU and forward some ports. It's nothing super amazing. You can also use libvirt if you like libvirt, and when you install it, doesn't really matter. There's no difference. And the image is now booting, and I should be very quickly able to SSH into it. This is the scary part of the demo, because it worked like 20 times in a row. Good, it worked. So this is the image, and we can go over the customization. So Fedora 37, let's quickly verify it. It is Fedora 37. Let's see if the container is running. So the container is there. Yeah, it's the image that I had in the blueprint. I can even you can even see that the image is installed. I can even curl to there. Yeah, there is something. I can even show you in the browser that if I go to the localhost 8080, it's there. I just forwarded the port, so that works. So everything is good. And what's there? What's next? Next was this was shown. Oh, let's show the partitioning. So if I do df-h, you can see that var is there. It has 10 gigs or 9.8. Oh no, it has 10 gigs, right? So the custom partition is there. And yeah, what else? Firewall. So firewall. Let's see if I can do it on the first attempt. List all? No. Oh, good. So by default, Fedora enables the HTTP v6 client and MDNS, and we added HTTP and SSH. So yeah, this also worked, and the firewall is actually enabled. And I think, oh, I added the user, yeah. And the user, yeah, sure, I am logged in as admin, and it didn't ask for a password, so apparently my key is there, and I used sudo without any password. And yeah, that's my demo. And I think that I am almost out of slides. Yeah, I am totally out of slides. So yeah, Image Builder. I think that it's a great tool, and not only because I work on it, but also because I like it. And I think that with these new options, it can get you pretty far if you need a customized image. There is a lot that you can do to basically build your image, push it into a cloud, launch an instance, and it will run its workload as intended. So yeah, this is Image Builder, and I'm glad that you were here for this talk. And if you have any questions, please, I'm here to answer them. Good.
So, aside from the AVM output, you also have outputs for each of the different clouds.
Yeah.
How do these differ?
That's a great question. So I will repeat it. Thank you. So the question was, how does the environments, I showed QCOW, but or QEMU, but there were also, you know, Azure, AWS, and other ones, and how do they differ? So there are some slight differences. For example, on Azure, you want to install their Azure client. It can do some more integration. Azure agent, agent. On Google, that's the same thing. Google has their own agent. So you want to install some extra packages. And yeah, also sometimes the configuration is a bit different. For example, it's not done actually for Fedora, but maybe we should do it, by the way, CloudSig. EC2 really recommends that all the distributions has EC2 user as the default user. Fedora has Fedora, so this would be something to configure just for EC2 images, which would be, I don't know, quite cool. Yeah, and the package sets, the kernel arguments can be different. I think that for CentOS Stream, we are disabling some drivers because they are causing some issues on some instant types. So the differences aren't huge, but I think that making like images per you know suited or tailored to the target environment, it makes sense. Oh, sometimes you need to take care also about like bootloaders a bit. Yeah, hope that answers the question.
The image type, you still produce QCOWs too or whatever. It's just what's inside the image.
No, yeah, oh, right. That's so. The question was whether we always do QCOW too. No, it depends. For example, for AWS, we will build a raw image because they accept only raw images. For OpenStack, it's QCOW, and for Azure, they need stream optimized VHD images. So we will provide that. And of course, then for the non-clouds, you know, ISOs are produced as ISOs, and yeah, that's it. Yeah. Neil?
So I saw you do, for configuring, for the dropping in of the file, you configured sudoers through that.
Yeah.
The sudoer file format is awful and terrible, so why isn't there like some kind of declarative stanza for it instead so that people don't screw them up? Because it's not like you get to use vsudo while you're making those drop-in files that'll possibly break it because you didn't format it correctly.
So the question was why we don't have a customization that would simply allow you to alter the sudoers drop-in to allow a passwordless configuration. Yeah, that's a great suggestion. And actually, a funny story, when we introduced the etsy customization, yeah, I got a report from a colleague that it doesn't work, it screwed up his environment, and yeah, he forgot like something in the file, white space. So I think that's a great suggestion. And our team is trying to actively seek for input so we can integrate more stuff that would help. And this is a great input. Thank you.
That file format is terrible.
Indeed.
So many times handwriting it.
Indeed. Next question, there was, yeah.
Any plan to support non-RPM-based distributions?
Well, Red Hat pays me, and we use only RPMs, but if a community member comes and does some stuff, for example, the guy next to you did some work for Arch Linux, then we are not opposed. We want to build everything. Especially Arch. No. David? Sorry, you mean, okay. We are out of time. I can answer this after the talk. Okay, good? Good, okay, we are done. Thank you.
Are we good? Alrighty. Hello, everyone. My name is Davide. I'm a production engineer at Meta on the Linux user space team. This talk is about what we're doing with ELN and how we're using to test upgrades on the production fleet at Meta. The agenda for today, we'll start with a quick introduction about what ELN is and how it's made. We'll talk about what we're specifically doing with it at Meta, what we got out of it, and how you can get involved and maybe get some value out of it as well. So, without further ado, ELN stands kind of for Enterprise Linux Next. There is an explanation of the puns in the name on the website that I will not try to repeat. It is a continuous rebuild of Rawhide using the CentOS macros and toolchain. So the idea is that every day we take Fedora Rawhide as it is today, we rebuild it using the same macros that would be used as if we were cutting a new CentOS string train today, and we put the compose out. So you can take it and use it, and you get a preview of what CentOS stream would look like if we were starting today. It is part of the development process for Stream and for RHEL, and it is used for this ongoing process. That's the link to the documentation. I'll add the slides on the website later, so you don't need to worry about the links. So here's how the sausage is made, more or less. Development work happens in Rawhide all the time. Rawhide is continuously rebuilt into ELN. ELN is used to test how these changes would look like in the future CentOS stream release. At some point next month-ish, I believe, the first branching for stream will occur. And at that point, we will have a new set of branches and a new set of repos and everything, and that will be Stream 10. And then Stream 10 will be stabilized, and then eventually we'll have RHEL 10 and so on. By the way, if you're wondering about the colors, this slide comes from an older presentation I gave. The orange boxes are because those are all things you can actually contribute to and work on if you would like. You can't contribute to RHEL unless you actually work at Red Hat, which I do not. So how this actually works is that the composes are made using something called the ODCS, which is the on-demand compose service, which is a thing that is able to make distribution composes and put them online so people can consume them. The package itself is defined in the Content Resolver, which was an offshoot of the Fedora minimization project that is still developed. If you go on Tiny Distro Builders, you can see the actual package set and play with it and slice and dice it. That's a picture I took of yesterday that gives you an idea. You can also see kind of the ebbs and flows in this. As we get closer to the branch point, you can notice this is getting lower because I guess folks are realizing they don't really want to maintain stuff long term for 10 years, so they're chopping it out, which seems reasonable to me. Now, this is just for ELN itself, which is what will end up in CentOS Stream and in RHEL. Most people, I would say, do not run just that. They need additional packages that you generally get from Appel. To test those, we came up with something called ELN Extras. The idea within ELN Extras is an additional set of packages that are composed together with ELN, but are not going to be part of ELN itself. It's still kind of in flux how we're going to do this, but the general idea is that we will use this set of packages to bootstrap Appel 10 so we can get a head start there and try to make life a bit easier both for users and for packagers. This is also defined in Content Resolver. You can look it up there. You can actually contribute your definitions here. So if you maintain packages in Appel and would like to get started or have them ready for Appel 10, you can put up a PR against that GitHub project. There's a little YAML file you have to fill in, and your packages will end up getting continuously rebuilt in ELN. Now, of course, this means you sign up for maintaining them. So if they break, you will need to fix them. But you'll need to fix them eventually anyway. So, and again, that's the package set. This work is coordinated by the ELN SIG, which is a Fedora SIG. We hang out in Matrix and in IRC. While ELN is primarily a thing that is happening on Fedora and Red Hat infrastructure and uses a lot of internal components, work on the project is by no means restricted to folks that work at Red Hat. You're welcome to join and hang out there. There's regular meetings on Friday where it's discussed. These meetings are also good to hang out if you're curious on what's going to happen in Stream 10 down the road. I'll talk about this later, but this has been very useful, for example, to get ideas, features that might be coming down the road that you'll want to know about if you actually run this in production. And here's a link on details about the SIG itself. So much for the intro. Let's talk about what we're doing with this at Meta. Before I do that, a quick primer on the infra at Meta. As you might have heard, Meta has a lot of machines. We have millions of servers. These are all physical machines running in data centers across the world. They all run CentOS Stream right now. we always run CentOS. We started with CentOS Linux. Well, I started in 2012, and we were running CentOS Linux 5 back then. We went through several major release transitions. So we went from 5 to 6, 6 to 7, Linux 7 to Stream 8. We just about finishing now Stream 8 to Stream 9. I was very happy to discover last month that we got rid finally of the last CentOS Linux 7 hosts. So we don't have those anymore in production, so that's nice. So I could put 2022 on that line. I expect we'll be done. We'll probably have a long tail of 8 stuff at the end of the year, but we should be mostly done with it by the end of the year. Right now we're at 86% on 9. There's still some containers on 8. Actually, 8 is still, I think, the majority on containers, but containers are comparatively easier, I would say. And for context, whenever we do this migration, we provision the whole fleet. We don't do in-place updates for production systems. So this is wiping the machine and reinstalling, which is fairly expensive, as you might imagine. Now, our customers don't love these upgrades because they're kind of expensive, because you're wiping their machines, they have to spend time qualifying the distribution. Usually, the way this has worked in the past is that we get CentOS, the new CentOS Stream release drops, we start working on it, we put it out, we will play with it, we find some major issue that delays everything by 6 months, because that's how it works. Like, it's absolutely normal. When you have a large deployment, it's pretty common to end up having to deal with these things. With 9 in particular, the SHA-1 deprecation ended up being a fairly sizable annoyance, because we had a lot of packages that predated that had to be rebuilt. We also had a lot of packages coming from external vendors that had, shall we say, questionable packaging practices that required a lot of work. So in general, we had been looking at ways to make this process better and more streamlined. When we did 9, I actually started working on this, started working from the very first beta that came out, and that helped quite a bit because we could get a head start basically since branching time. But you still get kind of surprises, because while if you follow Fedora, you kind of know what will probably end up because you know where it's branching from, it's hard to tell until it drops. The way we do this better is if we could start this earlier, and that's kind of where ELN comes in for us. The idea with ELN is using it so that we can streamline bring up of major OS releases. Turn this from a thing that we have to do at qualification time when a new major release drops to a thing that we do all the time. So we can continuously validate what's going to come down the pipe, find issues as they come up. When something comes up, we can either figure out internally if it's we that we fucked up and fix it, or if it's something that we have to discuss with the community because maybe there's a better solution that can help everyone. It also allows us to identify policy changes early on, things that will come in the distribution that might impact us, things that are being deprecated, new things that are coming up. And because this is a continuous effort, and because we start long before, it's a much more pleasant experience for customers, because instead of having to deal with, oh, all my packages don't install anymore, and I have a month to fix it, now it's all my packages don't install anymore, but this isn't a production system, maybe I have a year to fix it. It's much nicer. People are a lot happier when you tell them they have a year to fix it and they can sort of sort it out at their own leisure. And longer term, we would like to have an actual CI platform where we continuously roll out ELN on production systems for some value of production, so that every customer with different workloads can get a sense of what's going to come in down the pipe and do this validation at their own pace. Now, to do this, we started actually bringing up ELN in our infrastructure. And bringing up ELN is about the same effort as bringing up a new CentOS Stream release. So this was broken down into getting the repos, hooking them up into our update pipeline, adding them to our config management system, which is Chef, actually provisioning and building provisioning image and provisioning machine, and then deploying it and qualifying. And pretty much every step here involved fixing bugs, mostly on our end. So starting from repos, the repos come from ODCS, as I mentioned. There's the daily-ish snapshot or weekly-ish, depending on when it's cut, shows up there. We didn't particularly want to scrape that with wget-r because that seemed kind of bad. So we worked with the infra folks at Fedora to get rsync, to get an rsync endpoint exposed from there so we could mirror it using rsync. And now we have these exposed on our public mirror. So if you want to access that and you don't want to hammer the Fedora servers, you can use the mirror on mirror.facebook.net. I believe we sync that daily-ish, so it should be reasonably up to date. But we don't consume that directly internally. We actually snapshot it via another process that we'll talk about in a minute called rolling OS updates. Now, this is only for the base repos, but of course, there's also Appel. So for Appel, we use the ELN extras that I mentioned before. So we started populating 2 workloads in ELN extras, one for packages that we maintain as part of the CentOS Hyperscale SIG, which is where we do most of our upstream work within the CentOS project, and another workload for packages that are really specific to Meta that we felt it would be easy to have all in one place to keep track of. You can look this up. I put the screenshots here so you can see roughly the volume. The giant jump was when I started testing development systems, which have a lot of random packages on them. So I ended up adding a few dozens there. That's what this looks like for. And these are all packages that we'll be maintaining then in Apple 10, or at least assisting to maintain, because we're not the primary maintainers on all of these, obviously. Now, once we have the repos, we have to hook them up into our updates pipeline. I won't talk about rolling gas updates in detail here. I talked about this in other talks, and it's not terribly interesting because it's fairly internal to Meta. But the idea is that for CentOS Stream, we snapshot the production repos of Stream every 2 weeks. We roll them out on the fleet across 2 weeks. We do this via Chef, and effectively Chef will update the DNF.conf on the machine and run the DNF upgrade. And it just works, more or less. When it doesn't work, people get tickets and fix it. In the case of ELN, this process is much easier to some extent, because we just made a release train called ELN, which is going to be continuously updated. We snapshot it every day initially, because that made it easy to iterate quickly, and later every week. We don't really care about in-place updates for ELN, because what we really care about testing is the provisioning and the initial bring up. We don't particularly care about testing updates from one ELN from yesterday to ELN from today. So we just stubbed out all the tests for that and automatically promote all the snapshots. And this basically works. The only caveat here is that ELN composes can be broken, because we publish all composes regardless of state. So we need to filter for only composes that are tagged as finished. Otherwise, you end up trying to roll out something that is missing 3/4 of the distribution. Also, ELN extras workflows can fail. They can fail, for example, if you add a package that doesn't build. When the workflow fails, the entire workflow is excised from the compose, which is obviously bad. So right now, we just keep an eye on it, but I need to actually write monitoring. So we do the same thing and validate them before pulling them in. OK, now we have repos. We need to do the config management side. The config management side is fairly straightforward, with one caveat. ELN is odd in that it really is Fedora. It identifies itself as Fedora-oid. If you cat etc. OS release, it says Fedora-oid. The only way you can tell it's ELN is because it has variants set to ELN. However, everything else about it is CentOS. And we really want to validate it as if it were CentOS. So what we ended up doing was something horrible, which was adding logic to detect ELN based on the variant ID, and then monkey patching it so that it actually looked like CentOS. So in our Chef code, we have methods that do like if node CentOS, and those will return true on ELN. Do not do this. This is a terrible idea. And like we did this because it worked for what we were trying to do, but not something I would recommend in general. After that, it was just the usual loop of like testing it on a machine, iterating, finding there's, oh, this package is missing, and adding it to ELN extras, or oh, this logic is hard coding Sen9, but we can actually just flip the gate and make it hard code 8 because it's just a negative thing, things like that. Our open source codebooks are there. There isn't much that's ELN specific in there, but I put the link in case you're interested. If you use Puppet or Ansible or anything else, I expect it will be roughly similar. Frankly, I expected this to be a major pain, and it turned out to be very straightforward. OK, now we have config management, and we want to do provisioning. Provisioning at Meta is complicated. And to sidestep the issue, and because there's a circular dependency that you need Chef to have provisioning working, and vice versa, because the provision images are built with Chef, but you need machines to be able to test that Chef is working, we did another horrible thing, which was converting in-place existing CentOS Stream 9 hosts to ELN with DNF distro sync. To my surprise, this actually works. Not only it works, but it produces systems that still boot. Initially, I expected to do this and then throw the machines away, but they still booted afterwards with minor caveats. And I would not do this in production. It is a terrible idea. But it worked very well for development because I was able to take development systems, convert them in place, iterate quickly on the Chef stuff, and then later when the Chef stuff was sorted out, get the provision images going, and then we could provision machines from scratch. The provisioning system uses an internal thing that isn't particularly useful outside of Meta, but basically they're just images that get dropped onto machines, as you might expect. The images are continuously delivered and tested. They're So the provisioning system will build the image, try to install a bunch of machines with it, and then tag it if it's good or not good. Right now, we're at the point where we're effectively in feature parity with 9. We actually were able to refactor quite a bit of this logic to make it saner and better support future distributions. After that, it's just a matter of testing. So we started using, we have a small set of machines we call kernel tests that we use for doing kernel and hardware enablement work, which is very handy for these things because it doesn't run anything. So you just have to get the base OS working. So we got that going, and that took care of most of the basic chef stuff. Then we switched to doing the development servers. The development servers are great because nobody cares if like your own development server is broken. There's no services running on it except your editor. But they have a ton of packages on it because they have to support all possible work cases from like building the Android operating system to doing God knows what. So these are very useful for finding packages that were missing. We needed to add to ELN extras. We didn't quite know. Also, we were able to work with the folks that maintain these systems to discuss, oh, this thing you're doing here, maybe you should rethink it because it will probably break in the future. So this is kind of where we're at now. Right now, I'm working to expanding this to the container platform systems, which is the ones that I was actually interested in targeting since the start, because that's where the most of production actually runs, and those will give us a good measure of whether this will actually work long term. And also, the container system has extensive unit tests that should be able to tell us when things break very quickly. So let's talk about what we got out of this. It took about 4 months to go from nothing to having provisioning working. This isn't 4 months of like heads down work. This is 4 months of like spending time on this, but also doing other work. I suspect if you were speed running this, you could probably do it in half time. We now have some dozens of systems running on ELN. I can't say exact numbers for reasons, but it's not a huge amount. I expect this will expand in probably low thousands at some point. I don't think we'll ever have a large deployment of this because it doesn't really make sense, and because these machines will effectively not be doing useful production work. We have started conversation on wider deployments because at this stage, what I would like to see is different product owners at Facebook to start trying this out and evaluating. So say the database folks can use this to help the qualification for the databases in the future and so on and so forth. We've also began preparing for SendStream 10 because the work we were able to do with ELN made us aware of changes that might be coming in 10 that we should start thinking about. We are also able to start testing things like the NF5. Because ELN is built from Fedora, it has the NF5, so we can actually install it and play with it and test it and start integrating it. Changes that are being deployed and discussed as part of ELN can also be integrated and discussed internally. There's discussions ongoing. If you look at the meeting meetings for previous ELN meetings, there were discussions about, for example, dropping 32-bit packages. That's something that I was very happy to know ahead of time because I can start talking to the people that use them. And then, of course, we found bugs and we fixed bugs. And I will give you a few examples. So this was the very first thing we found, that when I put a machine up, immediately after converting it, I ran rpm-qa and I had a shit ton of errors. And they were all that weird invalid OpenGPG signature. So you might know that RPM for 18 ships with Sequoia, which swapped the entire OpenPGP implementation with one that actually works. Notably, this validates packages and makes sure the packages are actually compliant. It turns out our internal signing service was using a Golang library, and the Golang library was generating invalid signatures by design. Literally, if you read through the comments, it says, we know this is broken, we don't care. So that wasn't ideal. Luckily, we found out that the ProtonMail folks had a fork of this library that was actually compliant, so we swapped it in. This fixed our signing service, but of course, we had all of the existing packages that now had to be fixed. So we had to wait for a few mass rebuild cycles. We still have a long tail of these because not everything is auto-rebuilt, but it's at the point that it's manageable at least. If you have your own signing implementation, I highly recommend making sure this is not happening. Also, maybe don't use Golang. Now, this isn't all the fun we had with Sequoia. After we had the packages, we installed a system from scratch, and we saw our key wasn't importing. Now, you might remember I mentioned in Stream 9, the policy disallows SHA-1. Turns out RPM never validated the key at all. So when you imported the signing key on 9, it imported just fine, even if it was signed with SHA-1. Probably even if it was signed with MD5, I suspect. So this is a problem. Turns out the key was not actually valid. We were using a very old, funnily enough, it wasn't an old key. It was a key that was kept updated, but they kept signing with SHA-1 for reasons. So we fixed that, and then it was fine. There's actually a very handy tool that I got packaged into Appel for this, that was already in Fedora as part of Sequoia, and I branched for Appel, because SQ keyring linter, you can feed it a key, and it will tell you in human-readable form what is wrong with it. It also has a fix option where if you have the private key for the key, and it's an actual private key, not an HSM or something, you can just fix it and spit out a fixed key. That can be handy if you're your own key. If you have an HSM, you will need to work with your security folks on how to fix this. You may want to talk to your vendors about this. I audited ours. I would say at least 50% of repos that we were consuming were invalid. And most of these folks, when I talked to them, they had no idea what I was talking about. And it took quite a bit of effort to make people aware that this was actually an issue and they should do something about it. Also, if you're resigning your key, make sure you don't actually invalidate your key, because otherwise upgrades will be very painful for users, which actually happened with at least one vendor, from what I can tell. OK, enough about RPM. The other fun thing was util Linux. So Rawhide ships with the very latest util Linux 239, which is a lot of fun features. It also had a couple of regressions that we managed to hit. One was easy. They changed the option parsing for NSEnter. NSEnter has some bespoke logic for option parsing. That changed slightly, where you had to pass equal something instead of just doing option value. OK, we fixed it. That wasn't a big deal, I would say. That was also easy to work around. The more fun one was the mount API. There's the blog post that explains the mount API. We discovered this when I started provisioning machines that they never came up. And I would go on console and see a slew of error coming from systemd. And then when I finally managed to find where the console password is, I would get in and see that the root file system was read-only. And if you passed RW on boot, it would boot fine, but it would, for the life of me, I couldn't get it to remount. And if you try to remount manually, you get einval back. Turns out there is a bug in util Linux that if you're running an old kernel, it doesn't quite detect that the mount API is fucked, so you should use the old one. Funnily enough, I was talking to Aidan the other day, and this was actually independently discovered in Rawhide thanks to OpenQA. But we don't run OpenQA for ELN, so on ELN this leaped through. This is fixed in util Linux, by the way. I think I put up a PR to backport it in Fedora. I don't know if that got merged, but I'm sure it will get sorted out quickly there anyway. But this is a good example of something that we were able to catch quickly and get sorted out in a way that is hopefully beneficial for everyone. There's also a couple of other things I wanted to mention. By the nature of how ELN is built, it is like 98% like CentOS, but not exactly like CentOS. So first of all, sometimes just people playing fuck up. And it happens. In this case, we found that ODD was installed using the Fedora role set and not the RHEL role set, because there just wasn't any logic in the package for this. I guess when it was branched for 9, the maintainer probably branched it and then just updated the CentOS side of it and never backported the changes. So that was easy. Put a PR, do the conditional. We only noticed it because in Chef we disable ODD, and the way you disable it is different depending on whether it's the Fedora or the CentOS role set. The more interesting one was systemd. So you might know that systemd has this thing called presets that defines what services will start up on boot, on force boot when you install the package. So it will tell you when you're installing this package, should the service be enabled or disabled by default. The presets from Fedora and the presets from CentOS are very different because the use cases for the distributions are different. ELN uses the Fedora presets. So you might want to keep an eye on this if you deploy these. The way we found this out is because Fedora explicitly disables systemd networkd, which we want to explicitly enable instead. And we never actually did that. We just, because there was no preset for it, it would get enabled by default in our case. So that's something that caught us by surprise. I don't think there's, we've discussed this with the SIG, there's not quite clarity right now on how this is going to be handled on the CentOS stream side after branching. I expect this will probably keep deviating because there's not really a good way to manage them. But that's something else you should probably be aware of. All right. So what can you do with this? Well, as I said, CentOS stream 10 will be branching soon. There is a thread on Devel that I would encourage you to read that talks about the plan, how the branching is going to happen, when it's going to happen, how this will work out. You also have about 2 weeks to get a system-wide change in Fedora if you would like. And getting a system-wide change in Fedora now has a higher chance of it maybe ending up in CentOS stream. Definitely a higher chance of having to do less paperwork than later, because once it's branched, it's a lot harder to get changes into stream for obvious reasons. But also, if you maintain anything that runs on stream or on RHEL and you would like to get a head start, this is a good time to start playing with ELN and trying it out. It's also a good time because once Stream 10 is fully branched, ELN will transition to 11. And we'll be able to start doing this all over again. As I said, you can join the SIG. The SIG hangouts on Matrix and on IRC. The channels are bridged. If you maintain packages in Appel, you can contribute them to extras. That's a link to the ELN website in general that has information and details about the project. The documentation itself is on GitHub, as is most of the code that controls the build itself. And the Fedora minimization work and content resolver is what actually controls the set of packages that you can find there. And I will be happy to answer any questions. Yes?
You said you didn't find out about this through OpenQA because we don't know OpenQA or ELN. We could. Would that be helpful?
Yes, that would be very helpful. Oh, and the question was, we found this out because we didn't run OpenQA on ELN and whether that would be helpful. And yes, it would be very helpful.
Which bits?
So I think in general, testing composes would be useful. Which set of tests, I think is something we would need to, we would need to sit down and figure out. I don't know if doing the same test that we do for Rawhide is useful. I expect a lot would fail just because it's a very different system. So maybe looking at what kind of tests are done as part of qualifying Stream and RHEL on the other side of the house and seeing if it makes sense to port those to OpenQA, maybe. That could be interesting to look at. Any other questions? Yes? Oh, yes. I meant to add this, but I didn't know where to slot it in. Yes, there is support. There are shows for ELN. There is also support for Packet to build against ELN. Yeah, so what we actually do is for our open source projects, we use Packet to get continuous builds and signals so that when folks internally land changes, they won't break the open source builds. And we build this in Copper for all the releases, including ELN, for packages branched to Appel. That works really well. Neil?
How do you install ELN?
So it depends. There are ISOs. How do you install ELN was the question. So there are ISOs that you could theoretically use. I have never tried them. What I would do is the DNF install root process that you use normally to build images, or you can use your favorite image builder. Dan, who is there, landed support for building ELN images in MKOSI the other week. So that's an option. I believe they should work with any other image builder. It should work with Kiwi probably too. Yeah. But yeah, in general, I think this will depend a lot on what you want to do with it. Any other questions? Dan?
Could we fix the preset issue by providing a Fedora ELN release package that
So that was the question I actually had, and that's where the discussion started. The question is whether we could fix the preset issue by providing a Fedora ELN release package with the RHEL presets. The problem is that we don't know what the RHEL presets will be, because you can't just blank use the ones for 9 because it's different enough. And my understanding is that the way these presets are developed as part of Stream is that they start from the Rawhide ones, and then over time they get morphed into the new ones.
I don't know much about how Fedora ELN is developed, but I participated to the Fedora kernel development for ELN.
Mm-hmm.
And it's the same. You don't know what it will look like, but as time goes, you figure out the configuration things
Yep.
you want to change and you integrate it. So I don't see it as a problem for the little that I know. You could just start with the ones in RHEL 9 and then they get adjusted sooner or later.
I would be in favor of having something because it would make my life easier. It's definitely, I think it's definitely something we can revisit. This would be a good argument to discuss in one of the next SIG meetings.
In the ideal case, you actually just take the Fedora Rawhide ones as is and then evolve them separately as the software set
Yeah.
changes. Because like the way that it worked out with Stream 8 was they took the presets from RHEL 8 and it led to a broken system and people had to copy things from Rawhide into it bit by bit until things started working again.
So for the kernel, we have the advantage that we have, of course, every 2 months a new release, and we can look at what configs changed. But perhaps you could have somebody that, or a bot that every time the presets change in the Fedora Rawhide package, open an issue on the ELN package so that people actually take a look at the change and decide what to do.
I think that's a great idea. Yeah, and to repeat for the stream, the proposal was that we have a process where whenever there's changes to the package in rawhide, an issue is filed to see if the corresponding change is meaningful for ELN and for the future stream as well. I think that's a great idea, and it's probably something we should look at. Yes? Neil says that's probably meaningful only if the package is forked. I don't think so, because you might have packages where you want a service to be enabled in Fedora but not in Stream because it's not supported, because it's not part of the default set, you know. You had a question back there?
Yeah. So now CI was for ELN when the baseline change happened for x86.
Mm-hmm.
That actually this thing started to break on all AWS instances. Is this something that you also saw internally? Like, was this helpful for discovering this, or was it?
So I haven't seen breakage from this just yet. I expect I will at some point. I knew about this change because it came up in the last meeting. And to repeat for the stream, there's a change in ELN where it will use x86 64v3 as the baseline for x86, and this will cause breakage because anything older than well, I believe, don't quote me on that, will stop working.
So what weights exactly, sorry?
Any hardware that is older than a certain CPU generation, which is probably Haswell, will stop working. We haven't seen breakages from this in production yet, because the systems I was testing this on were all fairly new. I did start inventorying stuff. I don't have hard data on this, but I am fairly sure we would see some breakages from this, and this is something we will need to deal with. Yeah, I think there's a long enough window, though, between now and when Stream 10 and RHEL 10 will be released, that I expect it should be less painful than it looks like now, hopefully.
The big breakage I'm aware of is that booting up in KVM is broken by default because the default CPU doesn't support anything above the baseline for x86 64.
That's changed. That might be changing.
That should be.
I don't know when, but it should be changing sooner rather than later. Certainly it will change in ELN. I hope it will also change in rawhide. It's not specific, but I'm pretty sure it will change in ELN. And also one interesting change is that even if you, by default, until QEMU 7.2, there was no EDX support, so there was no way to do it with the tiny code generator.
Mm-hmm.
But now it's implemented. So right now, if you don't use KVM, you can, or you cannot use probably KVM, you can actually run ELN because it supports EDX.
Yep. And to summarize for the stream, one area that's impacted by these is VMs, because KVM right now, by default, uses, QEMU uses an unsupported asset that's older than v3, but that is getting addressed and should get backported to rawhide as well, hopefully.
Probably should have tested VirtualBox because that's the default thing, right?
Yeah, but I mean, we should have tests for a lot of things. But yes, I don't disagree there. I haven't done much testing on the virtualization stack, so I don't have signal on my end on this. I was going to talk to the virtualization folks on my side to see if they could hook this up in whatever they do.
I contact me and the other virtualization folks at Red Hat as well.
Sure, will do. Thank you. Anything else? Going once, going twice. All righty. Thank you very much.